And okay, folks. Well, today is October 30th, and tomorrow is Halloween. So, here today, we're about one chapter behind. So, chapter 20 is the chapter we're going to cover, and we're going to try and get through 21 and 22 today. Where should you be? Well, the midterm is over. You should be finished with the midterm. Also, you should be up to chapter 19 quiz, not 20 because I didn't cover it, but you should be up to chapter 19 quiz, should be done. And the midterm should be completed. If you haven't finished that midterm or started that midterm, you might want to get it done because we are now half over with this class. And if you look on the midterm, it was over chapters 1 through 15. So you could have completed it the last 2 weekends. And it requires that lockdown browser. It doesn't stop you from, it's not timed and it's not proctored. So it doesn't stop you, let's say, going to another device and using the quizzes as reference because they're over those chapter 1 through 15 quizzes. Okay, but the midterm's done. You should be done with chapter 19 quiz as well. As far as labs go, you should be up to UNIX Lab 8. First UNIX lab was just to load CentOS, basically. And the second lab was to get a web server working and the server status screen as well that goes along with that. So that was basically setting up a Unix web server. Does anybody have any questions on the schedule or where you should be at in the class? Okay. So let's start the lecture here. Give me 2 seconds. Okay. So storage. When you look at Unix, even if you're looking at the other side, you're looking at, let's say, Windows, well, we have different elements of storage. And, sometimes people get mixed up between what's memory and what's storage. And let's see. Give me 2 seconds here. I was surprised the other day. I was talking with a student and they were getting mixed up between what is storage and what is memory. Okay. I just want to make sure everybody understands. If you haven't, we do teach like a PC kind of break it down and look at it kind of class in class. If you haven't taken that, I would encourage you to take that class. But normally you have CPU, okay, central processing unit, basically a computer chip that does and takes data and takes all those ones and zeros and process it. That's a simplistic term. You can have multiple CPUs, and each CPU can have a certain number of cores. Or you may have one CPU and 4 cores, one CPU and 2 cores. Okay. And that processing power really is what makes your computer slow or fast. But another item that can affect it is physical memory. Okay. And those are computer chips. RAM is what they'll often call that. Random access memory. And it is physical memory on your computer system, right? It's usually on the motherboard, usually comes in these little DIMMs. Matter of fact, I may even have one here in my drawer here because I upgraded not too long ago. My laptops. No, I don't see one. But anyways, this can also perfect, and I'm going to put here, you want at least 4 cores nowadays on the CPU. One CPU with 4 cores. The more, the better. Okay. And then memory, whenever I buy a computer system, this is what I'm looking at. I'm looking at, well, how many cores does this thing have? And then on the memory side of the house, you know, nowadays I would say 8 gig, and even 8 gig. I had to upgrade. This system came with 8 gig, but I had to upgrade it to 16 gig just because for this class I was loading so much stuff on it. So if you've got about 4 cores and 8 gigs on a system, you know, you've got a pretty good system. But me, I would be going for maybe 6 cores if I can get that best deal. Look for something on sale with 8 gig. But now here's the thing. So I got my memory, I got my CPU, but, and of course, this perfects, you know, this is what we look at for performance. The more CPU you use, when it gets up to 95%, slower your system gets. And it's the same thing with memory. Now, what memory does is it has the ability to basically go out and talk to storage. All of this, and it has the ability that we can create a swap drive. A swap drive works directly with memory in that if memory starts getting full, well, it can use some of the storage as memory. We call this virtual memory. I'm going to put a VM here for virtual memory. And so if I got 8 gigs here and I got 8 gigs of swap, so let's say I got 8 gigs of swap, well, that I got a total of 16 gigabytes of memory. Okay. And the operating system has the ability to basically swap from physical memory to disk memory. Now, that means that that storage is, you know, pretty important, which brings us to our chapter here. When we look at storage, we look at I/O, input and output. And there's a lot of input and output on a computer. I mean, you got your keyboard that has input and output. You got your, you know, your mouse, input and output. You might have a USB drive or a USB stick, or, you know, you might have your network I/O. So all of that I/O also causes potential delays. A lot of times when you look at a CPU over here, it'll have the system usage. So this is usage. I'm already spelling stuff wrong this morning. And you'll have to excuse me a little bit today, folks. My allergies are just bugging the heck out of me. I went for a little walk on Wednesday. That was a big mistake. The wind was like blowing, you know, everywhere. And so, you know, now I'm taking allergy medicine. And so, anyways, so when you look at CPU usage, some of that CPU is taken up by sys, or in this case, the operating system. Okay. Might be taking up, let's say, 30%. And then you have user. User are the programs you, the user, are running. Okay. So let's say that, you know, these are apps that might be running on the system, or even multiple users if it's a shared UNIX system. And that might be taking up 20% of CPU usage. And then the next thing you get is I/O wait, or sometimes they'll just call it wait time. Okay, I'm going to mark that down, wait time. That wait time basically is the amount of time it's waiting on I/O. I/O could be sending something out to storage, or I/O could be memory swap. And usually that's what it is. When you look, it's going to be memory swap. And, oh, that might be 20%. So the total would be, say, 70% CPU usage. Okay. And when it starts getting up to, like, say, 85 to 95% solid all the time, Well, it's time to start considering upgrading the Unix system or your home system. Okay. But the other area that as I mentioned, is this IO weight. This IO weight, the higher it gets, what that means is the CPU is sitting there doing nothing, just wait in a wait state, waiting on, waiting on IO. And if I have all this swap going on right over here between physical and disk, well, then what happens is this IO weight. Well, I've seen IO weight get up to, you know, 30, 40, 50% because, one of the disk drives had problems. And so it was constantly waiting on that IO. So storage is very, very important. It's important because part of that storage is going to be used for swap, okay? So that we can swap memory in and out if needed. We usually monitor that, and if we start getting a lot of swapping, well, then it's time to look at adding additional physical memory, okay? Physical memory. So that storage, though, is also important because as we process this data down here, I mean, here's this storage down here. Here, we'll add a little storage. Down here is, all of the data down here. And of course, there's percentages with storage as well. If you have a computer system, I mean, let's say right here, I'm using up 40%. All this right down here that I've just, kind of colored in here, that's 40% usage. That's not bad, right? But if I start getting up to, there we go, here's another storage over here. If I start getting up to 90% storage, then it's time to look at additional storage. Part of the problem is that sometimes you will have this storage, well, it then starts cutting into swap or it starts cutting into temp. A temp directory is where we store temp files. So if you start filling up a file system and you start running out of temp, well, the operating system may crash because it no longer has the ability to store temp files. Now, saying that, how did they fix that or resolve it? Well, they created a separate /temp partition, a /temp partition. So storage is really important. The speed of that storage is also going to say, well, how much time are we going to be waiting on IO? For example, I could have a database on this storage that we see right here. And as the CPU processes some type of data, it has to move that data in and out of storage. If storage is slow, well, wait time increases. So two things that increase wait time is going to be memory swapping or storage going back and forth to the storage to pull in data. Now, what is storage? Well, it can be a hard disk. A hard disk, if you remember, a hard disk is comprised, and don't get me for my drawing, I'm not an artist, of a physical spindle and magnetic media, meaning it looks like, I'm sure a lot of you have seen, let's see, oh, I got these on my desk. If I want to burn a DVD, here's a DVD, okay? Physical disc is the same thing. It's just this media isn't plastic. It is basically a, hard encoded. It's got a coating on it that is magnetic media, okay? And then riding over that magnetic media is a head, a little disc head, right like this, riding over the top of that disc. And there is a bottom one down here. Here's a bottom one. We can't see it, right? There's a bottom one. And the disc spindle spins around and the magnetic media is red. It basically has the ability to influence or write to it with ones and zeros. Okay, that is a hard disk drive. Okay. Let's see if we can find a nice little image. Right here. Here's a beautiful image. There you go. Looky there. And so see these little heads, there's a little motor in there that spins these around. And then we write, basically, we're changing magnetic properties of this platter right here to either a 1 or a 0. And then see, look, some of them have multiple platters. I just drew one to give you the idea. Multiple platters and two heads. One that spins, on top of this and another one on the other side. And then add that to multiple spindles. See, look at all of these disk drives. I really like that one. Okay. So now let me ask you this. How big do you think one of the first disk drives was, and how much data do you think it could hold, folks? How much data do you think the first disk drive could hold? Here we go. Yeah, about 10 megabytes. Okay. About 10 megs. That's it. Now, I didn't work with these, but I mean, look at this. This is like really old here. I mean, that's hugely old. And then here you move to this, but you see the one in the back? I worked with some of those in the beginning. Okay. They were about, they would have, here were the platters, and we would go in and have to replace the heads on these things. There's what a platter is, about the size of a record, And, all of this right here that you see, one of these would hold about 10 megabytes. Okay. And then you get something like this with 8 platters, which is like 80 meg. I mean, if you think about, and by the way, I've got a couple of these in my garage. I've been meaning to get them out, and I wanted to make a clock with them. I wanted to, take the center of it and make a clock. But I got 2 of these platters that I replaced, and I've kept them all these years, and they're actually in the garage, in my garage. And I've said, okay, one of these days I'm going to get it out of the garage, and I'm going to make a clock out of it and hang it on a wall. Okay. But they had basically removable platters that you can see. And what we would do is basically you had either removable like this, which it actually had a case with it that you would lower into it. So that's the first storage, hard disk drives, and they are physical media that, it moves around. Now, as you can imagine, that spindle that's going around, well, the speed of the disk is dependent upon how fast it is spinning. Also, because you have literally, this tiny little piece, this head that it goes over the top of it. As it gets older, it can potentially scrape the disc, destroying the disc and making it useless. And that's why we'd replace them, because those heads would go bad, and they would go bad, and we would have to right here. Here's that case. See, they'd have this case right here, these different cases, and you would lower this platter inside and twist this, and the case would come out. And but what would happen is that the heads would touch and literally destroy the magnetic media. Next is a flash drive. Most of you know that because you carry some type. I mean, there's many types. Here's a flash drive here that I've got in my hand. These are pretty amazing. There's also one that I thought was interesting. Look at this. I got one that's shaped like a key. Okay, it's like a key, and it actually goes with your keys. I used to carry that around a long time ago, and now you can get ones that have gigabytes, Here's another one, another type, right? And you undo it. So you got tons of flash drives out there. You can make them bootable devices, and you can boot your PC to a different type of operating system, right? And it's pretty cool the size that these things have become. 32 gigs, 64 gigs, 128 gigs. I mean, flash drives are just. Oh, let me show you one more. Hold on just a second. So here's a 64 gig. I use this with my Raspberry Pis, but I mean, it's hard to believe that this right here, let's see if I can get it to come in and stop going over it. Hold on. So right here, it's hard to believe this right here, this little blue piece. Well, that's 64 gigs. 64 gigs. That is about the size of my thumbnail. You know, I mean, this is just crazy, isn't it? 64 gigs for thumbnail, and they have 128s of this as well. Okay, and then this fits into your Raspberry Pi right here. See, right in that little slot, and it basically acts as the storage or the disk drive for my Raspberry Pi. I mean, it still just amazes me how small memory is. I mean, we used to do a board that was 128K, 128K, and it was huge. And yeah, these things are cheap. They're cheap. Okay. And it always amazes me when I look at that and go, okay, how come this is so cheap? Or I can buy similarly with a 64 gig USB stick, how come it is so cheap compared to, well, I want to upgrade some memory in my system. I just think it's kind of funny. I think it's just the way that they want to try and generate revenue. It has nothing to do with what the real cost to manufacture it is versus what they could sell it at. They want to sell it as much as they possibly can. Okay. Just as an example, years ago, I wanted to see, well, how much would it cost to put a pool in my backyard? And they came up with $30,000. And I was like, what? And I'm like, it's a hole in the ground with water in it. And you want to charge me and a little concrete and metal. Okay. And I'm sure it's probably got about 5,000 in material, and then the rest is all, labor and, our profit in there. So, anyways, the next one you have is an SSD, a solid state device. Same as, very similar to what I just showed you, except that it is in a disk drive style. Okay. And that is pretty interesting as well, because those have, come down in price. I mean, look at this. 240 gig, $30. 2 terabyte, folks, $180. 2 terabytes. So you used to $180 is what the 250 gigs used to cost. Because I bought one. I bought one when they were 250 gig, and it was like I think I got about 130. Okay, to upgrade my laptop several years ago. Okay, but look at this, 2 terabyte. Here's 169 for 2 terabytes. So you got 2 terabyte SSD drives. I mean, it's just crazy. The price. Ooh, what is this? This is 10 terabytes, a little, times 10, $1,300. There you go. You can get a 10 terabyte. I mean, it's just crazy. It is crazy. And then there's our SSD drives right here. They are, um, they are solid state devices, meaning there's no spindle in them. So there's no spindle. We got rid of the spindle, and it's just memory, really, and it acts as a disk drive. And then you have a RAID array. A RAID array can be a composite of either hard disk or SSD, but a RAID array is where we have a bunch of disk drives. They call this a redundant array of independent disk, okay? But you have these disk drives. And let's say you got 1 terabyte, 1 terabyte, 1 terabyte, and 1 terabyte, but you need a 4 terabyte array. You need a 4, you need a 4 terabyte partition. Okay. And when I talk about partition, folks, I'm talking, if you want to go to the Windows side of the house, I'm talking about a folder, a 4 terabyte folder that you can store 4 terabytes of data. Okay. A partition in the Unix world is where we mount a particular folder, if you want to translate that into Windows, or a disk drive with a certain amount of space to create a specific folder, although we don't like to call them folders, a directory that allows us to store, okay, a certain amount of data. So for example, remember I mentioned the /temp? Well, we could have a /temp directory that was, say, 100 gigs. Okay. And that would be a partition. We would say, let's mount the /temp partition. Okay. So what this RAID allows us to do, and you can either have software RAID or hardware RAID, is combine these. I can actually combine them either software or hardware wise. If it's hardware, it's usually has a RAID controller in it. And I create a 4 terabyte partition. Okay. Now I can do more than that as well. I can do some redundancy. What do I mean by redundancy? Well, right now it's 4 terabytes. But if I lose a disk, I've lost the entire partition. It's gone. Good luck. All you have to do is lose 1 disk drive, go bad, and you've lost the full 4 terabytes. However, RAID software allows us to have some redundancy. We can do what's called, and we're going to see this here in a minute, RAID 5. And that RAID 5 allows us to take parity partition, they call it. But basically, I would only get 3 terabytes of usable, and 1 terabyte would be used for parity. It's a way that we can make it fully redundant, meaning if I lose a disk, I still operate. It's using that parity partition or pieces of the data that it copied on a particular partition on the disk. Okay. And that's another thing with partitions. When we say mount a partition, we're saying because we took a disk drive and it can have 1 or multiple partitions on it that we created when we formatted the disk. And then last, and by the way, there's mirroring where I can mirror 2 disks. We'll see that here in a minute. And the last one is storage area network. This is a SAN. This is where we get speeds. It uses a fiber channel controller card, but a SAN or a storage area network. In the back, we'll have a huge box out there, and it'll just have disk drives upon disk drive upon disk drives. These things, folks, get as tall as a refrigerator. So there I have all these disk drives in there, and it gets as tall as a refrigerator with disks upon disks upon disks. And it's a way to centrally manage storage. How do we do it? Well, once all the disks are in there, you then have to run the software that comes with it. It actually has inside this thing its own controller. And in some cases, it has 2 controllers for redundancy. And then it'll have a way to basically, and usually what you have is you have a fiber channel switch that it plugs up to. fiber channel switch. And then in the back of all your servers, you have a fiber channel controller card. So you have all of these servers out there, and their controller card is hooked. And it gives speeds as if it was physical disk, as if it was a hard disk. I don't want to say SSD because it would SSD is still going to be faster inside, but SAN is just as fast as if you had a hard disk. And they use RAID inside it to make sure that it's redundant. Hard disk versus SSD, well, we should all know they're a ton faster. A hard disk drive, 8 milliseconds versus an SSD, 0.25 milliseconds, tons faster. Yet I would usually buy my system. Now they pretty much come with SSD drives, but I used to buy them with a standard disk drive, and then I would go out and buy a SSD drive and install it myself as the primary. And literally it boots up in seconds versus minutes. And these prices, as we've seen, they've come way down since this. Now, when it comes with storage technology, you do have what are called different interfaces, meaning how does it plug up inside your PC? Or how does it plug up outside? You can have, look at this. I've got this sitting here. This was an older PC, and I stuck the disk drive in it when it went bad. This is a 2 terabyte disk in here from my Plex system. It's got all my videos on it, and it's gone bad. I bought a new enclosure that I've got sitting over here on the floor to see if I can recover it. But I also have another backup over there. So whenever you have an external closure, this could be USB. That's what this is. See that USB connection right there, the blue one, USB connection. Or it could be ATA. Now, some of this is older technology, advanced technology attachment. See, IDE. That's old. But that's what disks are. I mean, that's what systems had. Nowadays, it's serial ATA or SATA, we call it. 3 gigs to 6 gig is the speed. And then here's SCSI, Small Computer Systems Interface. They still use this in fast, wide, and ultra. This was just different speeds. And now you also have serial attached SCSI or SAS. Fiber channel is just that, fiber optic. But here's what the funny thing is. It's also copper. Never quite understood, that, okay, wait a second. If we're calling it fiber, shouldn't it be a fiber cable and not copper? But they're running the different protocol that it runs is running over copper versus fiber optic. Now look at this speed compared to these over here, 1 to 40 gig per second. So all of this is 3 gigabit per second, 6 gigabit per second, 40 gig per second with fiber. So the SAN storage uses that fiber channel connection. So we're talking about up to 40 gigabits per second. And then, of course, you have USB and FireWire, okay, which is 480 megabits per second to 800, a little slower. USB 5 gigs per second. Although I have never seen USB do 5 gigs per second as far as I'm concerned. I don't care if it does say USB 3 and this is the speed. I haven't seen that. No, I mean, it seems slow to me every time. You're like, okay, am I in the USB 3 port? Okay, I am. Yeah, that's not 5 gigs per second, or 5 gigabits per second. So here's different interfaces over time. Here's a Centronics 50 pin. I used to have a bunch of these connections in my garage, and I recently just chunked them because I'm like, okay, these were external connections pretty much. And these, you can see a ribbon connector. These were internal, but some of these, like this mini micro and the wide, those were external connections where you could hook up a box with a bit of storage in it. So I talked about a partition. And what that is it's a fixed sized subsection of a storage device. Traditionally, a disk can have multiple partitions, and a logical volume management is kind of replacing it. Now, here's what we used to do, folks. And as you know, this says it's kind of changed. We used to have, here we go. Here's a disk drive. And I'm going to put this, it doesn't store it in this way, but I'm just going to give this to you kind of for simplicity's sake. So what we could do is slice it up kind of like a pie. We could say, you know, okay, this is a 100 meg partition. It doesn't do it this way, okay, because, you know, it's floating around there. So I can take any portion of that disk drive to make this partition, okay? And there's actually a partition table on the thing that keeps track of where the partition ends and begins. I'm only putting it into a pie format for visual representation, okay? So here I could have, you know, 250 megabytes. Here I could have 1 gig. Here I could have 10 gigs. And here we'll say this is 5 gigs. Each one of these is a partition, but you have to format the drive to get this partition table and the partition sizes you want. You got to go in there and say, okay, I'm going to go and create and format this and put it into these partitions. This one here could be partition 1, partition 2, partition 3, partition 4, partition 5. You went in there and you formatted the disk and you created these partitions. You created them because you wanted to use them for a certain function. For example, this might have been /home. This one here, the 250, would be / for the root level. This 1 gig might be /opt, which is optional software. And the 5 gig here might be, oh, we could say /user. Something like that. And we create this partition table. Now, once we've formatted it, so the first step, we have to format it. The second step is we have to create a file system on it. We have to use a makefs command to create a file system that our operating system can understand. You see, if we just do the partitions from an operating system perspective, it can't read anything or write to it because it isn't created in a file system type it can understand. So we have to do a makefs on it to create those partitions, okay? I shouldn't say to create partitions, to basically make sure that it creates the file system on the partition, okay? And then once we do that, well, we can mount it, meaning that we can make it accessible to the operating system. That's what a partition is. Now, back in the day, we always used partitions, but as you can see, we can use logical volume management. Logical volume management, well, I can just create one large partition, say a terabyte, and then the volume manager can manage it. And we can create separate, see right down over here, separate logical volumes. We're going to look at that here in just a minute. Okay. The next thing is I could use a RAID array, a redundant array of inexpensive or independent disks. We can use multiple disks into one virtualized device, like I showed you, taking 4 1 terabyte drives and making a 4 terabyte partition. I can increase performance by using parallel reading and writing, meaning multiple devices, and I can increase reliability by either duplication, mirroring, or parity checking. Now, if we look down here from a UNIX perspective, this is how we manage storage. First, we can create separate partitions just like this. And I can take those partitions and I can pop them into a RAID array. So for example, I could have another disk that is a duplicate of this right here. And I can mirror partition 2 with the other partition 2. Have to be exactly the same size, but I can mirror them. This gives me redundancy, meaning if this disk goes down, well, the other disk kicks in. Or I could have a storage device. A storage device would be like a SAN storage, a big giant, a bunch of disks inside the computer room. And with that storage device, I can either create a partition that we could mount. I could create a RAID array with that storage device. Now, saying that, most storage devices like SAN solutions, storage area network solutions, they already have a huge ability to do a RAID array. So they'll do the RAID array inside them. Or I can either put a partition, a RAID array, or some other storage device. So I could go back to my storage device over here and I can say, okay, let me give 1 terabyte of space, 1 terabyte of space to this UNIX system. And the UNIX system then can just manage it with a volume group. Now that 1 terabyte will already be RAID array on that SAN solution. Now, when I create a volume group or groups, I then have the ability to create a logical volume that I would create a file system in. Notice, see here where it says file system, because I can take a single partition, do a new FS on it, or, well, new FS means new file system, or a make FS. There's a couple, 2 or 3 different commands we can do it with. But I can then create that file system. And then I could create the file system on a RAID array, or I could take a logical volume and create a file system on a logical volume. So volume groups and logical volumes, they're managed by a logical volume manager, meaning a program. It subdivides a pool of devices into logical volumes, similar to dividing a disk into partitions, kind of the other way, the opposite way. So for example, let's say I had a 750 gig drive and a 250 gig drive. I would take those 2 drives and make them part of a volume group. And then I would have a 1 terabyte volume group. But I could split it into 2 500 gig logical volumes if I needed 2 partitions of equal size. Next, a file system structures how the data is stored on the partition and retrieved. It mediates raw blocks of partition, RAID array, or logical volume. Let me ask you this. If I create a file system on UNIX, is that file system the same file system type that I would create on a Windows box? Yes or no in the chat session? What do you think? Yes or no? It's not similar, Lisa. It's a yes or no, and it's definitely no, okay? And Easton, it is no. So not an NTFS, okay? Every operating system that's out there has a file system that is their primary file system. Now, I'm sure that, what y'all meant was that, oh, yes, you could take another file system and read it on there. In other words, I could, and by the way, if we go back a few years, I'd say, no, you could not. But they have programs that will allow you to interface to other file systems. The thing is, folks, that where do you think that operating system is going to operate better? It's going to operate with a file system it understands, not one that it's, compatible or, oh, look, I can read an NTFS file system. For those of you that don't know, an NTFS file system is on the Windows side. So file system structures how data is stored and retrieved on that partition we created. It mediates raw blocks of a partition, RAID array, or the logical volume. Here is basically a bunch. Look at this. FAT. Well, FAT is basically the old Windows side. Started off with DOS, okay? File allocation, then it went to 16 bits, 32 bits, then they came up with NTFS. And then here, ext2, 3, 4, and or 4 is for Linux. But you have other file systems. You even have manufacturers like Veritas. I used to work with this. They wrote their own file system that was supposed to be better than anybody else's. And companies would spend, you know, thousands and thousands of dollars to get Veritas's file system on their environment. If we go to Wikipedia, you're going to notice, here we go, they talk about file systems here, but there are a ton of file systems in here. Let's see, where are, I'm not seeing, let's try and go to, this just talks about file systems in general, but the one that I want is, the one that shows the types. Used to be a nice little, see if I can find it here on Wikipedia. Yeah, there it is. Okay, so list of file systems on Wikipedia. Look at them, folks. You know, there are tons. Can you see? Now notice up here, EXT, Linux systems, EXT3, EXT4, they just improved it. Okay, but you have tons of file systems. ZFS was from Sun Microsystems with a Sun operating system. Okay, and pretty much if you read through here, here's UFS, Unix file system. This was also Solaris. And then they came out with ZFS, which was supposed to improve it. But if you look here, there are, you know, multiple file systems for depending upon what the operating system was. Okay, NTFS, here we go. New Technology File Systems by Microsoft Windows, and it first came out in NT, and it's still being used today. Here you go, HFS, Hierarchical File System for IBM's ZOS. Okay, so pretty much every operating system had basically a file system that was their file system that allowed their operating system. Look at this built-in tolerance. You know, here we go. We just keep going on and on and on. Now, yes, did they write a program that would allow you to say mount an NTFS system on a Linux system? Yes, they did. And can you read and write to it? Sure. But are you going to use something? Let me ask you this question. Are you going to go, oh, well, NTFS is Windows. We got a lot of Windows. So let's just use Windows to write instead of ext4. No, you're going to stick with ext4. Here's that example. As an example, in this case, we go out at the physical layer, we have a hard disk. And then we create, by running a format program, we create two partitions. And this is how we would access them. This under dev is those links to our disk drive. So SDC, notice, look, A1 and A2 are our partitions. We then create a file system, that ext4 or 3, and we create that file system so the operating system can read and write to it. Over here, we use the entire hard disk. Created one partition by formatting and creating one partition of the entire disk. And then here we call it /spare. We created that file system, and then we mounted it. Okay. And in here, this is just some diagnostic output showing you, look, target 3 is a SCSI disk. It's a Seagate model ST44652W. This is a 46 gig disk. Okay. Usually the model number would tell you about the size of the disk. So each operating system as well slightly names the device driver for that disk in dev a different way. So for example, Linux, dev SDA, and the partition would be dev SDA1. So this would be the whole disk. This would be a partition. Here, look at this, FreeBSD. Once again, slightly different. ADA0 would be the whole disk, and ADA0P1, meaning partition 1. As a matter of fact, if you look, P1, partition 1, HPUX uses that slight P1 to identify a partition. UNIX uses that A1 for the partition. And then you have usually the whole device, okay, or raw device. Raw device just means usually that you can notice in Linux, the raw device isn't used, but in Solaris, HPUX, and AIX, a lot of times we could use the entire raw device to do some replication, okay? But you have the whole device and you have the partition that you created. Could be more than one, too. Now we get into RAID. This is where now we have a bunch of disk drives sitting around, whether they're SSD or whether they're old style spindle, and we want to combine them. The first one is RAID 0. RAID 0 just combines. So as an example, if this was 1 terabyte and 1 terabyte, well, I would have a 2 terabyte partition that I could utilize. Okay, 2 terabyte partition. This just shows you that, okay, you could have basically another way that you can do things is, I just gave you an example of combining the whole disk. However, I could have a partition A. I could have 4 partitions in here. Okay, I could have 4 partitions. Those could be 1 disk drive, but I could have 4 partitions on a single disk, and I can take the partitions and RAID the partitions themselves. They just have to be the same size. Okay, the partitions themselves. So there's 2 ways that I can RAID something. One is partition. So I could have, let's say, a 1 gig and a 1 gig and create a 2 gig temp partition. Okay. And the reason I'll mention that in a minute. Or I could create a 10 gig and a 10 gig, combine them with RAID 0. That's what we're talking about right now. Come up with 20 gig. So I could theoretically do the entire disk. You know, each disk would have 1 partition, and it would be basically a terabyte and a terabyte, giving me 2 terabytes. Another way that I could do it. Another way. There's a couple ways you could do this. What you have to understand is we're just combining 2 or more drives of equal size into stripes. These could be disk drives. This could be, you know, a 1 terabyte disk, a 1 terabyte disk, a 1 terabyte disk, a 1 terabyte disk. Once again, equal size. They all have to be. So this could be 4 disk drives, and I would have 4 terabytes here, 4 terabytes, and I could combine them into a single 8 terabyte RAID array. Okay, so RAID 0 just means you're combining disks or partitions. Okay, you're combining disks or partitions. Next thing that I could do is I could use RAID 0. This does mirroring. What does that mean? Well, if this was a 1 terabyte disk and this was a 1 terabyte disk, I would get a 1 terabyte partition, but it would be mirrored. Meaning all of this data here is replicated to here. By the way, it does this on the fly because it's doing parallel transactions. It is the same data. Basically, if I had here's my PC, inside it I have this mirror, what happens is the data is being written at the same time, exact same time. The software, hardware RAID or software RAID is acting right here as an interface. So here's my RAID software, and that RAID software is doing all the magic. It's writing to both disks at the same time in parallel, and it's reading, okay, in the same manner. It's reading as well. It's acting as if it's one disk drive, but it's mirrored. Now, if I lose one, bang, off it goes. Doesn't matter. I'm still operational. Matter of fact, you'll experience no downtime whatsoever. None. Zero downtime. And you won't lose any performance either. No performance degradation whatsoever. You just have one disk. No big deal. Now, what do we do? Well, some drives are what they call hot swappable. Now, what does that mean, hot swappable? Well, that just means that we take the drive out. There we go. I'm taking it out. And I put a new disk drive in. And when I put that disk drive in, the RAID software, well, you have to enter a command. But the RAID software will rebuild that mirror, meaning it'll copy everything back over right here to this system. And then once it gets in sync, is what it's called. Once they're back in sync, well, then we're back to writing at the same time again. Okay, so it'll start copying all of this over to here. And then once it's done, we say, okay, it's synced. And that copying back, there is a slight degradation in performance. Not much, just a little. Now, what if we combine striping with mirroring, or mirroring with striping? That's what this is. This is where we take, let's say, a 1 terabyte disk. And by the way, I'm doing it by entire disk, folks. We don't have to do that. We could, like I said, I could use partitions as well. A 1 terabyte, and notice RAID 0, so I'm creating a stripe. RAID 0, I'm creating a stripe. So I'm taking and creating a 2 terabyte partition here and a 2 terabyte partition here. But this is striping. RAID 0. Let me ask you this. If I lose this, do I lose all of the data in this stripe right here? Yes or no? Do I lose? So here we go. Here's my stripe right here. Draw a little box around it. Here's my stripe right here. If I lose a disk here where I mark the X, do I lose all of my data in a RAID 0? And the answer is yes, folks, I do. All of this data here is gone. It's gone. Goodbye. It is striping. Striping is just where we combine two disks. Okay? It is not mirrored right now. That's not mirrored. Mirrored is RAID 1. That's why I wanted to make sure y'all understood. RAID 0 is striping. RAID 1 is mirroring. RAID 1 is mirroring. Okay? So, this stripe down here that we've created is 1 terabyte, 1 terabyte, and all we did is combine that storage into 1 2 terabyte storage. But if we lose one of them, that's it. It's gone. Goodbye. This section over here, that section is gone. Okay, goodbye. Now, if we want redundancy, we then take this 2 stripes, combine them together with RAID 1. That creates a mirror of the 2 stripes. But I'm only going to get 2 terabytes because we're now mirroring these 2 stripes. There's the mirror. Okay? Everybody got that? Answer yes or no. I want to make sure you understand that. Everybody got it? Okay, awesome. Now, we could do it the opposite way. Kind of sounds kind of funny, but we could do it the opposite way. Notice down below here. Hold on a second. Let me erase a little bit. Let me erase everything. Look down here. Here I am mirroring. So I have 1 terabyte and 1 terabyte. And this is RAID 1. So it's mirrored, meaning both of these are exact copies. But I only get 1 terabyte of storage. On the opposite side, this also is running RAID 1, which is mirroring. And now, if this is 1 terabyte and this is 1 terabyte, I only get 1 terabyte of storage because it's mirrored. Now, if this disk here goes, am I still good? Yes or no? Does all of the data over here still good if I lose that one on the left? Yeah, it is, because it's mirrored. It's RAID 1. RAID 1 mirrored. So I'm good. I am good. And now what we do is we stripe it, meaning we just combine. So look at this, RAID 0 stripe. So now we have a 2 terabyte partition. It's a stripe. It is a stripe. And as you can look, it does have quite a bit of redundancy because, you know, if I lose this down here, is the stripe still intact? Yes or no? Is the stripe still intact? Got 2 no's right off the bat. Why would it not be intact? Is this not mirrored? It is. It's mirrored. So if I lose this disk right here, well, it's mirrored. This one's going to carry on. So the stripe is still intact. Okay? Yeah, without some type of mirroring, Lisa, without some type of mirroring in this configuration. And that's both configurations do mirroring. They just do it slightly different. One of them does it here, right here. Oops, hold on. It just depends. Both of them have performance differences. So this here, stripes first, meaning combine the disks first, then it RAIDs them. Then it mirrors them. Sorry, then it mirrors them. So, and hold on, let me get rid of everything. Back to the pin. So what you look at is RAID 1. So in this case, these are RAID 0. So we are striping these 2 disks right here. And here we are striping these disks right here. If we lose one of these, we lose the entire stripe. But it doesn't matter because we got another stripe over here mirrored. Here, we are mirroring first. We're going to mirror these two discs right here. We're going to mirror them. Same thing over here. We're mirroring first. And then we combine them into one big stripe. If we lose this, well, we're not losing that entire because we mirrored, okay? This one here still works. Okay, any questions on this? Answer no in the chat session or feel free to ask a question. The way to combine stripes and mirrors. They do this for performance, and this is how a SAN storage array works. Yes, all the disks would have to exist on one system, Nicholas. So all these disks would have to exist on that system. This is not done from one computer to another computer. Okay, it's all the disks would have to be on my computer or in that big storage array in the back, or they make smaller ones. They make smaller storage arrays. Hold on a second here. Let's type in here we go. So I typed in RAID array for sale. And you'll notice here I have, you know, these enclosures. Sometimes they look like this. So this is storage, 32 terabytes with Microsoft Windows. Ooh, I'm not buying that one, sorry. Intel Pentium processors. Let's say RAID array with RAID controllers, because really you don't want software. You know, software is a little bit, you know, overhead. So here we go, 24 terabytes, 4-disk drive with enclosure, disk storage. Let's see if this comes with, just out of curiosity. Oh, look at this. Includes Soft RAID XT, the most powerful software RAID utility. Okay, but is it hardware controller? See, this is a RAID 5 4 drive. So this is what we're talking about. We would have this, you know, we could have this hooked. Some of them come with fiber channel controller cards in it. And you can hook this up with a fiber channel controller card to a server. But if we look at here's a SAN array. Here's a smaller one. The ones that I have worked with, and I shouldn't say I've worked with most of the smaller ones. So this is basically a storage array, SAN. You would hook to a switch, and you can imagine that if you had terabyte SATAs in here, how big that would be. But the ones I'm looking for, which are probably not going to be here, are, you know, the biggies. Let's see. Let's not go shopping. Let's go images. There we are. So see, you get these bays, like a whole cabinet, but just looking to see if I can see one that, you know. So here, look at this. Here's SAN right here. A storage array network. And look, here's what this says, a baby. So this is a small one, you know, and you get these literally the size of refrigerators with tons and tons of storage. I work mostly with the smaller ones like this, where, you know, it would be a few terabytes or, you know, but nowadays we're talking, you know, 140, 240 terabytes of, you know, look at this, enterprise SAN storage solutions. You know, let's see. That's what I should have typed in, was enterprise. So you get these huge cabinets that you buy, and they, you know, just have tons and tons and tons of storage. Look at all of this. That's all storage, folks, right there. So that's just huge. Okay. Okay. Let's talk about the last RAID level, 5. So as you can imagine, when you mirror these disks, it gets expensive, right? I mean, you literally have, if you kind of think about it on usage, you literally just have an entire disk that you paid for. So here's $1,000 disk, and here is I spent another $1,000 just to have it sit there acting as a mirror, waiting for the day that one of them will go down. That gets to be expensive, extremely expensive. Because if you think about it, if you're duplicating every single disk to run in a mirrored state, well, it's going to get expensive. So they come up with a technology called RAID 5. What it did, see how you have a P, P, P? Well, that stands for parity. Okay. And I'm not going to get in depth as to how parity works and the ones and zeros work. You know, maybe if this was a, you know, more computer science degree versus technical degree, you don't really need to know that. All you need to know is that when we do RAID 5, it creates a separate partition, meaning a separate area on each disk, okay, to keep track of the entire array, okay? Now, what does that mean? Well, here I've got 4 disk drives. And just like with mirroring, you're still going to lose some data. So let's say I had 1 terabyte, 1 terabyte, 1 terabyte, 1 terabyte. I'm going to lose, with this RAID 5 partition, I'm going to get about 3 terabytes. Notice it's not the same as mirroring. As mirroring, I lose about 50%. With for redundancy, I lose 50% in redundancy with mirroring. But with RAID 5, I lose about 30%. This is what we normally store home directories on. Mirroring we use if we want really fast, high-speed storage, like for databases. For databases, we'll use mirroring. But we will use RAID 5 for like users' home directories. So for these user home directories, I've got 3 terabytes. If I lose a disk, I'm still operating. Now, there's a problem. I do lose performance, meaning it's slow, because what it's doing is it's using these parity partition right here, which has some of the data from this. And so I'm losing, basically, because on the fly, it's using these 3 remainder partitions to build the data on the fly that this disk has now lost us. And until you put the disk back and resync, it continues to operate slowly. Now, what you can do, and what a lot of people do, is, although some of you are going to say, are we getting up to the 50% now, Professor Wade? Yes, you are. You know, we can add a hot spare. And by the way, we could have done the same thing with the mirroring. So you'll find those, you know, SAN solutions, or what I just showed you a minute ago on all those images, that will usually have 1 or 2 drives in there as hot spares. What that means is the software will automatically, when this goes down, it'll automatically start syncing those parity partitions over here, rebuilding the data, and now we're intact and there's no performance degradation. RAID 6, very similar to RAID 5. The main difference is that it has basically 2 parity disks, similar to similar to RAID 5, but it has 2. And you'll notice that it's got this, where's it at? It's got parity, and it's got this Q here. So a Q and parity and Q and parity. So it has not quite two parity partitions on each one, but it does have a little bit more parity, similar, and it works similar to RAID 5, but it takes a little more than 30%, more like 40%. There are other RAID configurations. We could go look at them on Wikipedia. Which RAID should you choose? Here we go. Let's go look at Wikipedia. Give me 2 seconds to get this down. So here you go. Here's the RAID. There are discusses. You can go to that link and take a look a little bit more on RAID. And you also have, they'll often call, here, here's the nested RAID levels. Here, see RAID 0 plus 1, 0 plus 3. They'll often call this RAID 10. RAID 1 plus 0. That's where you're mirroring and then striping, And so they'll often call this RAID 10. Okay. And then you have basically RAID 5 and 0. That's where you're doing RAID 5 and then you're striping 2 RAID partitions together, RAID 5 partitions, or you're striping 2 RAID 6 partitions. Okay. And, and then look at this. If you look at this, this is the most complicated. You got a mirror, a mirror, a mirror, a mirror. So mirroring at the base. Then you create a stripe, and then you create a stripe of a stripe where you're combining that. And to me, this one was kind of stupid. This is overkill because you could have just created one stripe with all 4 of these. Okay. As a matter of fact, I'm not even sure why you would want. I'd have to go read up and go, why do you want to do that? Because I've never done that. Okay. So which RAID level should we use? Well, it depends. If you need no redundancy, we can use a stripe. For example, temp space. Temp space, a lot of times, we don't need to keep it. Matter of fact, when we reboot a Unix system, the temp directory, all the contents disappear. It's gone. Gets rid of it. So we could use a RAID 0 partition for temp. RAID 5 has redundancy, but slower on the write. So if it's write intensive, meaning a database that just constantly bombards it, we don't want to use RAID 5. We'd rather do mirroring. It has redundancy and faster writes, but it is costly, meaning it's more expensive because you're losing 50% of your cost, or you're incurring 50% more. You're doubling the cost of the disk storage. And then other combinations, RAID 1, 0, RAID 10, or RAID 1 plus 0, mirroring and striping, or striping and mirroring. Try to find a balance between the 3 of these. We can have hardware RAID or software. On Linux, it's called MD, multiple disks. And it is MD admin, which manages it. So for example, take a look here. MD admin, and remember sudo just escalates our privilege. MD admin create /dev MD0. So that's the partition we're creating. Create RAID level 5. We want to use 3 devices, SDB1, SDC1, and SDD1. So 1 partition between these 3 devices. Now, folks, these partitions could have been the whole disk. When we create a partition, it could have been the entire disk, or it could just be, 10 gigs or 100 gigs or a terabyte, or, a portion of that disk drive. Now, these 3 partitions have to be exactly the same size. Exactly the same size. And see how it says array dev MD0 started. If we go look at var log messages, see how it says disk 0, 1, and 2. So SDB1, SDC1, and SD1 are arrayed array. And then it gives us the number of blocks, which is the number of size. But we can also then, at this point, we're still not ready to write to the device. All this did was create a partition, a RAID 5 partition, and we still have to do new FS to it. And we would do the new FS, which is new file system, or make FS, make file system, to dev MD0. So here they're just basically setting it SDC1 defaulty to kind of show us what it looks like. But let's say it goes down. I got 3 disks, one goes down. We're still operating, folks. RAID 5 lets us operate. Now, if I lose 2 disks, well, then I'm not operating. See, it says disk failure. And so now we have a disk out. Notice here, if I do a cat proc mdstat, that's not normally what we do. We just do the mdstat command. Gives us some information about the RAID, but we're still operating just fine. Because RAID 5 is redundant, the array continues to function in a degraded mode, though. It is slow. So users won't necessarily be aware of the problem. We got to monitor this. Got to have a monitoring tool to constantly monitor to tell you. I mean, funny story. I was hired by Accenture for the state of Texas, one of the state of Texas organizations here. And they weren't having much reliability in their data center. And they wanted somebody who had a lot of data center experience, which was me. And they also wanted somebody that could liaison between the different departments and the company that was managing this. So the first thing I did is I said, well, let me install some monitoring tools. And my boss is like, well, they already have a monitoring tool. I said, I agree, but they don't want to give me full access to it. And how do we do a comparison? How do we know their monitoring tool's configured correctly? And he said, okay, go ahead and do it. And that company, not the company I was working for, but the company that maintained the data center, they didn't like me too much because I deployed these monitoring tool and immediately found problems. Some of the RAID arrays had lost the disk. And I said, well, I've got 5 servers that need disks replaced. And I opened tickets and they're like, well, how are you finding this out? What are you doing? You know, and I'm saying, well, I installed my own monitoring tool. So that monitors the RAID, which is what you should be doing. Why don't you know this? It is very important to monitor it. And I had learned from experience on RAID arrays as well. We had a RAID array in one company. We bought, you know, just like you saw, one of those boxes with tons of disks, and it had a RAID controller on it. And we configured it, and all of a sudden, every once in a while, well, every few months, we'd lose an array. A partition that was in it. Partition would go down. We're like, what's going on? And we'd log into it and find out that, and finally it clicked on me. Are we monitoring this? Did we ever put it on monitoring? And, you know, and we're all looking at each other because it was a team with multiple administrators, and they're like, no, we never did. And we're like, yeah, maybe we should monitor it. And we did. And like, literally we operated that thing for the year. And like, we couldn't figure out, like, every 3 or 4 months, you know, the array with a lot of data was no longer available. And we are like, well, we configured this thing, you know, it should be working. It's RAID 5, you know, why are we continuing to lose all these disks, and what's going on here? Well, it turned out that we were losing a disk and we didn't use any hot spares because we had them cold spares sitting on the shelf. And we didn't know about it. We weren't being alerted. So then what would happen is, in our RAID array, what was happening was we were losing basically a disk, and it was operating. You don't know it's gone bad. That's the way this works. And then we'd lose a second disk, and that's when it would go down. And then we'd have to go. And all we were doing was going back and redoing the array with the same disks, the 2 that were bad, and loading the data back on. And it was getting us by another 3 or 4 months until finally, you know, I started thinking about it. And I'm like, you know, because my boss is like, we need to figure this out. You know, we've had this device a year, and we keep losing disks, you know, our disk arrays. And then I said, and then it clicked to me, wait a second, is it in monitoring, you know, when we installed this? And it wasn't. And so once we monitored it, we would see when the disk went out, and then we go in there and we'd remove it, replace it on the fly. It would resync. And after about 6 months, we lost 2 or 3 disks in it, didn't lose the array. And then it was stable for like 2 years, you know, because, and so what it was there was 2 or 3 disk drives that were bad, and it was causing the arrays that they were attached to go out. Okay. So that is one thing that we can do. We can use the MDADM software to do RAID 5, or we could have done mirroring. I could have done mirroring as well, either, or I could have done a RAID 1 plus 0, you know, the stripe them and then mirror them, or I could have mirrored them and then stripe them. Okay, so I have the ability to use this RAID software. Now, this is running as a software, not a controller board. If it's a controller board, there are chips on the computer that have the software firmware. So it's really firmware. Let me ask you this. You think software is faster, software RAID or hardware RAID? What do you think in the chat session? Software RAID or hardware RAID? Which is faster? Yeah, software is not fast. Hardware RAID is the fastest. Logical volume. A Linux logical volume proceeds in a few distinct phases. First, we have to create and initialize a physical volume. We have to add that physical volume to a volume group. Then we create logical volumes on the volume group. So here, another way, what this is doing is, you know, you still, and I will tell you this doesn't have redundancy. It wasn't designed to be redundant. So you still want to use some type of RAID array for the redundancy. What volume groups and logical volumes do is they allow you to create a pool of devices and then be able to, you know, increase them or decrease them on the fly. Okay, that's really what you're doing here, is you're allowing that if somebody says, hey, I'm running out of disk space in the home directory, oh, okay, we can increase or decrease. You either might have a storage device like a SAN solution that has built-in RAID array with it, that allows you to create that RAID in a large SAN solution, or you might just have a box, a smaller box with, you know, RAID in it as well. Or, as you just saw, if we have a bunch of storage, we could run RAID ourselves, software RAID ourselves, like you just saw one slide ago. But once we have either created a partition on the disk, created a partition on our storage array, or created a partition using our RAID array, we can pipe that into a volume group so we can slice and dice the data up as we want. And when I say slice and dice the data, I mean you can create a file system of the size you want to mount on your system. It allows you to better manage resources. So that's why we use volume groups, so we can manage the resource a little better. In other words, if somebody says, I need a terabyte, we give them a terabyte, and then we go, oh, a terabyte, and 6 months later, we're like, well, you've only used 100 gig. Yeah, I thought I needed a terabyte, but 100 gig is fine. Oh, great. Well, we're going to go back and we're going to take 800 gig away from you and put it back into the volume group. Okay. So the first thing you have to do is initialize the physical volumes, meaning the RAID array, the partition, or the storage. You have to go in and you have to use a format command to figure out how you're going to partition them, or you have to how you're going to partition them and then put them into an array, or how you're going to structure it on the device. You have to make that available then to the volume group. And once you've added those to the volume group, well, now you can create those volumes of what size you want and mount them on the physical storage. So here we go. Here's some of the commands. Notice Linux, HPUX, AIX, and the commands are very similar. I mean, if we look at this, PV create, this creates a physical. So here we go. Here's the logical volume. Here's the volume group, and here's the physical volume. So we run, and by the way, right below this would be the format command. So the first thing we do would be format the partition, get the partition the size that we want. Maybe it's the whole disk. Then we create a logical volume. We go create logical volume. We do a LV create for Linux, HPUX, and AIX is make LV. So AIX, which is IBM, has to be different with their OS, but Linux and HPUIX are very similar. Matter of fact, the exact same commands. Once I create that logical volume, and see, look at this, I can resize it as well. And you can do this a lot of times while the user's still working, and all of a sudden they log in and go, oh, I got more volume. Great, thank you. And then here, once I've created that logical volume, I then add it to the volume group. And I create a volume group. Then I have to, as part of that volume group, I have to go in and put which logical volumes I want into the volume group. Next, once I have the volume group, well, I can create the physical volume. Okay, I want a 100 gig partition. Okay, I want another 50 gig partition. Okay, I want another, because maybe this is 10 terabytes or 1 terabyte. Okay, folks, let's see who gets it right this semester. Every single semester, I tell students this, and it always amazes me that some of them still don't get it right. On one of the quizzes for this chapter, one of the questions is, what is the Linux recipe to add a disk? Okay, I say, what is the Linux recipe to add a disk? And this is the answer right here. And yet I'll get folks that they'll just put format disk, or they'll, no. Okay, here we go. So regardless of your OS, it's critically important to identify and format the right disk drive. This is the Linux recipe for, adding a disk drive. Create a partition for the disk. So first we got to go out and use a partition. And even before that, see it says format, you have to format it. Once you format it, you create a partition table for the disk. So it's either CF disk, F disk, SF disk, parted, or G parted. One of these programs will basically, so all you have to do and answer that question is say, create a partition table for the disk drive and add this. And then the next part is this. Here, look, we have to create that physical volume. So we created a physical volume. We called it dev SD1, C1, sorry. Then we added that volume to a volume group. Maybe this is a terabyte drive. And by the way, we could have added more. I could have said dev SDC1, dev SDD1. I'm adding the partition, but you had to do this create, because what it does is it goes and it basically creates that logical volume that the volume group can understand. Okay, I can't just go and say, okay, I'm gonna add I'm gonna create a file system on this and add it to the volume group. It doesn't work that way. It is a slightly different format that it's doing to that particular partition that you created on there. You created the partition right here with one of these programs. So if I just make this a little more visually, here's my disk drive. I could take the entire disk drive and make this might be drive C, and this would then, I would go in here and say, okay, I would use one of these programs. We'll use FDisk. That's the one I used a lot, although I have used Departed, but FDisk is what I used to use. You use FDisk, and we create a partition 1. That is now called SDC1. And in this case, I'm going to do the whole disk, 1 terabyte. Over here, I got another disk. In this disk, I am going to create multiple partitions. So here's partition D1. And this is going to be, let's say 200 gig. D2, 200 gig. D3, 400 gig. Okay, I'm going to create basically 3 partitions. Now, over here, we're going to use this exact example. Now that I got the partition, I'm going to go create a logical volume. A logical volume. It's going to go out to the disk. It's going to do some stuff to it and create a logical volume called SDC1. Now I'm going to add it to a volume group. A volume group. And after I add it to the volume group, well, the next thing I have to create is a logical volume. A logical volume is going to enable us to mount it to the operating system so we can start writing to it. But before we write to it, we have to create a file system on the logical volume, well, that we understand. In this case, look, file system type is going to be ext4, and I had to give it that volume group name / volume name. Okay? That volume group name / volume name. And then finally, I have to make a directory where we want to mount it, like /home. And I'm going to go modify the FS tab. The FS tab tells us what we want to mount and where we want to put it. Okay, give me 2 seconds. Where are we at? I'm looking for putty, my system again, and I keep, it's not on my desktop, unfortunately. There we go. I'll go search for it. Bring up putty. I'm going to log us into, or log me into, there it is. Okay, give me 2 seconds, folks, and then we'll take a break. We're almost done. Okay, so if we look at that FS tab and go cat, and we'll do a more FS tab. It's in ETC. Notice, look, see how I have dev, mapper, costs. See, that's a volume group, folks. You can tell it's a volume group right here because it's VG. Notice that this says when we boot, I want you to mount this device as the /home directory. And it's an ext4 file system. And over here, mount it as default. And then over here, you can tell it to run a file systems check. See where it says pass to? That means it's going to run a file system check. It'll check it before it mounts it. Make sure that it's not corrupted. Okay. Here, let's see what else we got out here. Look at this. Here's the swap partition, folks. This is dev map cost db volume group. So once you have the volume group out there, well, you can start slicing and dicing it. We don't necessarily know. It's not going to tell us, well, how big is this? But if I do a df -h, see, it'll show me /home is 69 gigs available, 84 gigs used. Okay, 84 gigs, and it is 161 gig total. So it's 161 gig partition, 84 gig is used, 69. But the advantages of having a volume group is that, okay, I got 84 gig. Maybe I want to put 50 gigs back to the volume group and use it for something else. Okay, notice over here I got the root partition as well as a volume group. And you got all this temp FS. So, once again, this is a question on your quiz. what is the Linux recipe for adding a partition or a disk? We create the partition table on the disk first, meaning we slice it and dice it how we want. Then we create, right here, we create that logical volume. Could be the whole disk, SDC1. We're just getting ready to add it to a volume group. We create the volume group and we add whatever logical volumes we want to add to it. And then here, we're going to create and slice and dice that logical volume so that we can mount it onto a system. So here we go, the volume name and the volume group name. We got to give it that volume group name that it's already in, what we want that volume name to be. Then we create a file system on top of it. Then we make a directory we can mount it with. Then we put it in FS tab. And once we put it at FS tab, we can just type in a mount command to mount it up. Mount space /home. We also don't need to necessarily, folks, put it into FS tab. We can mount it without, maybe we don't want it to mount automatically. Solaris recipe, look at this. We run format. I've done this a lot. I've run the format. And then, well, they have what's called zpool, which is the same similar thing. It's a pool of resources that we can then go and slice and dice that pool of resources. HP Unix recipe is exactly the same as the Linux. Look, prepare it for use with a logical volume with a PV create. And I've been calling this logical volume, folks. I should have called this physical volume. I apologize for that. Physical volume. You're preparing that physical volume, okay, to use with the logical volume down here where you create the logical volume, okay? I should have said physical volume, the physical device itself. And then that volume group create, we create the volume, we add the disk drive to it. And then here you have a VG display. It just shows you the information like how much free space do you still have in that volume group. And then you do a logical volume create. This is where we slice and dice the volume group. So we put a bunch of disk sources into a volume group, and then we can slice and dice how we want that volume group so we can mount it up as a directory or a folder. And then we create the file system on top of it. And by the way, we're not creating the file system on top of the volume group. We're creating it on the logical volume, a logical volume. And then we mount that logical volume. We created the file system. We make a directory and we mount it. We use a mount and the mount point command. Okay. That's HPUX. Linux, same way. AIX, a little differently. Make volume group and add the disk. Okay. And then here, this is where you're doing that, logical, that logical volume and the volume name. And then you're doing, look at this, CRFS, not MakeFS for them, but CRFS, create file system. And then where you want it mounted, the amount of free space, then you make directory, and then you can mount it with that. Or we could also put it into their FS tab or VSF tab. Here's another example of an FS tab. Notice here, this isn't a good example. The one I showed you just a minute ago, ours is better because you're really seeing the slash here. You're not really seeing a volume with it. You're seeing a UUID or a process with it. I don't really like the way they've got it. I would have used a different one had I been the author. But yes, we can, if we have a CD-ROM or a floppy disk, that's really old, we could use that. Not a good example by the author. This was taken from the book. The one that I gave, a minute ago is more of, this is more what it really looks like because you're actually looking at it. You're seeing here that we have the volume group for home right here and the volume group for root, which is our main operating system partition. And then we designate what it is it ext4. So we can mount other operating systems from this. So mentioned earlier, like Microsoft, we could have an NTFS as long as the operating system supports that file system. But you always want to use an operating system that is applicable or that was designed for that operating system. In this case, Oct4 is designed for Linux. So that's what we would want to use. We wouldn't want to try and go, well, let's see if we can create a NTFS file system to run Linux with. You know, I wouldn't, okay, because I want the best performance possible. Folks, that's it for that chapter. A lot to storage. Any questions on this chapter? Any questions? Answer no in the chat session or feel free to ask a question. Okay. Well, that was chapter 20. We are going to take a break here. Let me get up. So let me close this off. Chapter 20. We'll do 21 next, but we're going to take a 10-minute break, folks. It is 10:20. Get you another cup of coffee so you can listen to Professor Wade's lecture and not hopefully, fall asleep. Or get you a little snack or take a bio break. And we will resume at 10:30, okay? Resume at 10:30 a.m. I'm going to stop my camera. Let me pause the recording. Let's talk about chapter 21. Chapter 21 is over NFS, Network File System. Now, before we go on, who can tell me, what do you think network file system is? What do y'all think that is? What do you think it means? When I say, hey, yeah, let's, network file system, what do y'all think? Just say not sure, or, if you want to have a guess, great. No answer is a wrong answer. Okay, well, maybe it's wrong, but hey, that's how we learn, right? NFS, what is NFS? Network file. Okay, Nicholas, accessing a file system on a remote computer, but how? How? That is a correct answer. Anybody else? Nicholas says it's accessing a file system on a remote computer, but how? I mean, I could log into that computer to access the file system as an example. Network file system. Anybody else want to hazard a guess? Come on, it's Halloween. I just spent $100 on candy for trick-or-treaters on Sunday yesterday. Yeah, there we go. Okay. Not necessarily VLANs. No, VLANs is more switches at layer 2. But the ability to mount a network drive, okay? Not so much data. But here's the thing, folks. Here's what network file system is. So they had to have the ability, and this is really the reason networks are here today. You have a computer sitting out here, and you have another computer sitting over here. So here I have, a computer, and we're going to say a server because, most of this technology runs on servers. And so here I have a server, and I have some data on there. Okay, I've got some data. And over here, I have a bunch of users, and they're using this server here. And I have a bunch of users over here, and they're using this particular server over here. But they want to exchange data. Hey, we need to send our data to each other. We want to, send the data. Now, there's a bunch of different ways, folks, that we could send data. We could use file transfer protocol to transfer it, okay? We could do SCP to copy it from one system to the other system. We could use RCP, although this is unencrypted, So we don't really want to use that. But there's a number of ways that, using FTP or SCP. But what this does is copy portions of the data. And do we really want our data to be duplicated? I mean, if this is, we'll say this is data 1 and this is data 2 over here, different data. But do I want to copy a portion of data 1 over to data 2 or data 2 to data 1? Why? It's already over there. I don't need to have it duplicated. Let's pop in another server. Here's another server over here, and here's some users using it, or there could be applications using it. And here is my network, and this has, data 3 on it. Different types of data on different servers. But in order to share the data, well, I could copy it over across the network using something, like I said, FTP, SCP, or RCP. Or not even the network. I could use a USB drive and go put it in one and put it the other. But do I want to duplicate this data? Do I want to have pieces of data 2 on 3 and 1 and pieces of data 1 on 3 and 2? No, I don't. I want all the data to be on their applicable server because that's what those servers do. Maybe they have an application or users that use that specific data, but some of the data needs to be shared. So I can use what's called network file system. It's a program that runs, and I can actually mount data 2 over here across the network. So if I wanted to, a lot of times on the Microsoft world, they'll call this a shared drive. Microsoft does the same thing. They don't use NFS. They have their own format, which I believe, their own format, which we talk about in the next chapter. But it allows me to basically create a shared drive over the network, in Microsoft terms. But it uses a different protocol called NFS. On my Unix system, I would just do cd change directory to /data2. And for all intents and purposes, it looks like data 2 is right on that server. But in reality, data 2 isn't on that server. What it is doing is it is mounting this partition, this file system over here, data 2, that's physically located on that server, and it's mounting it over here on this system. Likewise, if data 3 over here needed to have and view data 1 over here, I could have a /data1, and for all intents and purposes, it looks like it's there. But in reality, what it's doing is it is mounting this from here across the network. Remember that mount command where we would mount a partition? Well, in this case, we're mounting the partition over the network using a network protocol. So, network file system protocol allows the sharing of file systems among computers. It was introduced by Sun Microsystems, and it allows us to mount a file system from one server to another server across the network. It tracks the files on the network. You can either have stateful, where it'll track open files, and that depends on the version of NFS, or stateless, meaning independent. It doesn't keep track of open files. What does that mean? Well, that means if over here, the users on this server here opened up a file from data 3, well, we would want this server to know about it because we wouldn't want two people opening it up at the same time and editing it and ending up it causing some corruption. So you have stateless, which is the old version 2 and 3. And then when they came out with version 4 of NFS, they could actually track open files. There is, though, some performance issues in that because it's going over a network, you can potentially have network latency. Okay. Now, it dealt with those by trying to batch up requests or coalescing into a batch of requests from a server to server. Security. Well, with multiple machines accessing using NFS, there is a security concern. Because if anybody can mount it, well, it's not very secure, is it? But there is ways that we can go in with NFS and say which machine can have what privileges. For example, no, let's go back here. No, you're not allowed to mount data 3 over here because you don't need the data and we don't want you. Yes, over here, you can mount data 3 over here. That's fine. We can also say, but you can only mount it read only. You're allowed to read it. You're not allowed to write. Yeah, when we share this data across the network, we can say whether it's read, whether it's write, or whether it's executable. We can actually designate, no, you can't mount it. Yes, you can, but read only. Yes, you can, but read and write. And so we have the ability to share it between systems. Okay. So with security. So it does have some security functions. But once again, anything on a network, you always have to worry about, is it properly protected across your network? Some people will say, well, but it's in our internal network. Well, but guess where 50% of the hackers come from? Internal to your network, meaning your own employees are gaining access to something they shouldn't have and releasing it to the public. There's different versions. The beginning was versions 2 and 3. It didn't track open files between servers. Doesn't track which clients have the file system even mounted. By mounted, meaning mounted across the network. And it uses a cookie at the conclusion of a successful mount. And the cookies could persist between reboots, meaning it would mount it back up when it rebooted. NFS version 4 was a stateful protocol. It could track open files and locks on the files. And when the server failed, well, the client could send pre-crash state info. And then when it came back up, it would wait on the client to report the pre-crash state info. And cookie management no longer existed because in this case, we're actually tracking the files themselves and whether they're opened or locked between the servers. NFS version 4 was a major overhaul. There was compatibility and cooperation with firewalls and network address translation devices, integration of lock and mount protocols, stateful operation tracking open files and closed files, strong security. It also had some support for replication and migration, meaning we could, if we wanted to, create redundant partitions that we could mount from dual locations, okay? Meaning if I wanted a backup, let's say that, what does that mean? Let's say that in common, I had a /data partition, and I put the /data partition here and a /data here. In other words, two physical partitions here and here, and we could sync them up. And so if all these other servers needed /data, we could have them get it from server 1 or server 2, but if server 2 went down, server 1 would take up the slack. It's a way to replicate and have multiple NFS partitions coming from, multiple servers. Supports for both Unix and Windows clients. Look at that. Windows clients, meaning Windows could mount the NFS partitions. Access control lists, where we could do more finely grained privileges of those files. In other words, we could literally say, okay, imagine you've got these servers, and on the servers you have groups of people. And we could say, okay, only these groups are allowed. We could give different privileges to different groups with access control lists and give different privileges to different users as owners of those files. We could say, okay, well, you're allowed read and write, but not execute, or you're allowed read only these two groups, but you other two groups, you're allowed read and write. Support for Unicode file names and good performance over low bandwidth conditions. So they improve the protocol to improve the performance over the network. Security. All versions of NS protocols were intended to be security mechanism independent, and most servers support multiple flavors of authentication. For example, no authentication, or Unix style user and group access control, or RPsec GSS, a powerful flavor that ensured integrity and privacy in addition to authentication. Identity mapping is used in NFS version 4. For example, user at the domain, meaning, and UIDs and GIDs needed to match across the servers and clients, meaning I couldn't have an account on a server and it'd be a different UID. It would cause conflicts with the permissions, with the security. Had to be the same. So NFS server, we have to export the directory. The process is called NFSD, D for daemon, right? And mount D was used for NFS versions 2 and versions 3. So the process is NFSD, and then mount D was used for version 2 and 3. They also came out with a unique way of, let me go back here. So now that I can share this file system, I still have to mount it. There's 3 ways that I could mount data 2 onto this server. One way that I could mount this is with a manual mount command. So I could say mount data 2 onto this server here. That was one way. The other way is I could put it in the FS tab. We just looked at the FS tab. Yes, you can have NFS mounted partitions in the FS tab. Problem with putting it in the FS tab is if this server here happened to be down, or if data 2 no longer existed, well, you could cause performance issues with the server coming up because the FS tab would get locked. The other way was with a program called auto mount, and D for daemon, but auto mount. Auto mount would not mount the partition unless you did a CD to /data2. The minute you did a CD to /data2, the auto mount daemon would automatically mount it up. And if you terminated your session, you logged out, or you changed directory to something different and you didn't go back into /data for a little while, it would unmount it. So it would automatically mount it or unmount it. We ran auto mount D all the time, okay, on all the systems, because it was a way to reduce network bandwidth by not having it constantly mounted. The only time we would put it into the FS tab sometimes is if it was something that an application needed that data and it was used all the time, 24/7. But for the most part, we could use auto mount D every single time to either automatically mount it or unmount that network partition. Pretty cool. Startup scripts, well, you have NFS kernel server, okay, for Ubuntu. You have NFS server for SUSE. Red Hat has NFS. Solaris, NFS.server, HPUIX. Notice all of them have NFS. Notice most of them are in the init.d directory. And then remember, you have those RC directories, which are links to these files to say when to start it up. So under rc3.d, we would have a link to basically NFS, etc rcd NFS, and it would start it up or shut it down with either a K or an S in front of that. So file system exports, NFS servers maintain a list of directories. Now, what do I mean by NFS servers? Well, in some cases, we had just a server that had data on it and had a huge amount of data on it. And that's what we would use to share those file systems across the network. In other words, we'd have a dedicated NFS server. I gave an example of, hey, you got this server with this data and this server with this data and this server with this data. We want to share and talk. But another one is that we just have a single server, and it is designed as an NFS server, and it has, we'll say, 20 terabytes of data, has all these partitions, slash data 1, slash data 2, and so on. And then you have all of this servers, like a server farm. And all of the data would be over here, and then we would share it out across the network. Okay. So we used to have dedicated NFS servers with a ton of storage on it. And we would share that out to all the, for example, home directories. We don't want everyone to have an individual home directory on every single server. We want their home directory to only be one home directory across our entire data center. So home J Wade would be over on the NFS server. And when I logged in over here into this machine, if it was using auto mount, which is exactly what we would do, whenever I logged into one of these machines, it would mount my home network from the NFS server to whatever server I was logged into. Then when I logged out, there you go, I'm logging out. Eventually, auto mount D would time out and go, oh, well, hey, you haven't accessed this home J Wade directory in a while. I'm going to unmount it. Okay. Now, another thing is there were these, oops, hold on. Let me go back. When you configured that drive that you wanted to share over here, well, you had to export it, allowing it to be used as a mounted file system. And there was a file out there. On Linux, we call it exports. Solaris used DFS tab. And what it did was it said, hey, and this is the file too that would have the privileges in it. It would have the privileges of, well, when J Wade mounts home J Wade, does J Wade get full read-write privs? What about if somebody wanted to go into J Wade's directory, say over here, to get something out? Well, do we want to allow that? Well, this file contained that. Okay, contain the permissions. So once again, for Solaris and HPUIX, it's DFS tab. For Linux and AIX, it's exports. And if we made a change to it on the fly, we added another, okay, we got a data 3, and let's put all the permissioning in here. Well, you would have to do an export fs -a to get it to reread the file on Linux and AIX, and then share all on Solaris and HPUX. Now, we don't necessarily have to change this file if we're just doing, let's say we just put a data to copy something over here from the backup over here. And so we just needed a temporary mount or share. Well, we could actually type in a share command. This says share minus NFS, read write to monk a, these are server names. So I'm saying, hey, these two servers can do read and write, and monk, this server, can actually read or write as root, the /home directory. So here is also an example where we would have that home directory replicated on two systems, Monk and Leopard, and we would sync the two between them. It's a way to always have a home backup directory. Why? Well, imagine in this scenario, we only had one home directory here on this server, and instead it went down. Well, guess what? No users can now log in globally because they can't get to their home directories. They're in trouble. So what do? Well, we have two NFS servers. might be 20 terabytes. Doesn't necessarily have to be, but over here I have a home directory as well. And what I do is I sync them up. There are programs that you can actually do sync. Sync's the name of the program, actually. We can sync up the home directories. And then we can say in that auto mount D file, we can say which one's the primary and which one's the secondary. And so if this goes down here, well, it doesn't matter. I've got it replicated here and it'll kick in there. But I still have to do a share. There is my share command and say who can do what. So what I would have to do is say read write monk and read write leopard. Well, you two folks can mount the home directory. And I would have to do this on both machines. So going back to my example here, I would have a server over here named Monk. Give me 2 seconds. Monk. Here we go. Server. This is Monk right here. Here's Monk. And right here is down at the bottom. We'll call this one Leopard. So I want to mount the home directory here to Monk and Leopard. But what I have to do is I have to run that share command on both of these servers, which says, or if I did only have one, sometimes we only did have one just because it was a smaller company. But for the most part, we'd try to, in larger companies, we'd try to have, two. I would go to my NFS server and I would say, okay, I want to share /home with Monk and Leopard, meaning Monk and Leopard can mount it across the network, meaning Monk and Leopard can mount /home across the network. Both of them can do reads and writes to home. But Monk, if somebody logged in to Monk as root, they could do and have full privileges to /home to do whatever they wanted because they're root. Meaning that they could remove everything. They could accidentally do an rm-r of /home and it's gone. All of everybody's directories are gone. So you have to be real careful if you're going to trust another server out there to mount your file system and have root to it. Here I've got read write, a system called ROS and HARP, and it's user share man. So out here I would have user share man, and I'm authorizing two systems to be able to access it or to do read write. Here are some of those share commands. When we share our file system across the network, we can say it's read only. It's read only and give it a list of hosts. It's read write. It's read write and give it a list of hosts. It's root, meaning root can access the file system and make changes on it. Otherwise, root is not going to be able to make global changes to it. When I say global, I mean it bypasses any security. By the way, just because it says read write doesn't mean you can read write to it, because you still have the lower level file system privileges. Does everybody understand that? In other words, let me give you an example. Just hold on just a second, just to make sure that you understand. So here we go. Here I have my NFS server, and I have a /home directory that I'm sharing. And I would have to do something like this. I'd have to execute this command here. And you will notice that I've got Monk right there. So out here I have a server called Monk. And I just got through saying that Monk can do read write. So Monk over here, I mount my home J Wade. Now, in reality, this is coming and being mounted from over here. Let's say that another user logs into Monk and they go to home J Wade. Well, the owner of J Wade here, I may have home J Wade and if I go out and look and do an ls of minus al of J Wade, I would see this. I would say read, write, execute, minus, 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 minus. The owner would be J Wade. The group would be staff. And I'm sorry, this should be on one line, but I should have written it over. But remember the privileges. This is the owner. This here is the group. And this here is world or everyone. Just going to put world, everyone. Now, over here, I shared it out, read or write, but it's going to also look at the privileges of the directory, of the file system itself when it's mounted on the other one. Let me ask you. So if my username is J Smith and I log in and go to home J Wade, am I going to be able to read J Wade's contents, write J Wade contents, or execute anything in J Wade? Yes or no? Yeah, no, no. So this read write isn't a global read write that says everyone can read write to it. No, you still follow Unix procedures. Okay. Yeah, all it's doing is saying that yes, people can read and write to/home, but they still have to follow Unix permissioning. Okay. Now, if we don't execute this share command on our NFS server, you can't mount it over here. You can't mount it. And here's some other shares. Look at this. We can by host name, by group name, by DNS domains, by IP networks. But mostly this is the format we use for sharing. And then we say whether you can use root or not. And then here, look at this. Anonymous equal UID specifies the UID to which root is remapped. The default is nobody. So this is for Solaris HPUIX. Here's AIX. Access list equals read only, read write. You know, it's very similar format, right? Here's some more. Look at this. So remember that file that I talked about? Okay, that export FS file or DFS tab. Well, this is what it kind of would look like. So look, I'm sharing /home with a server called harp. I'm giving it read, write. I'm giving it no root squash. This means allow normal access by root. This is dangerous. And then Monk, a server called Monk, I'm giving it read, write. And then share man, I'm giving it to, see how it's .atrust.com? That means anything in my domain, any server or device in my domain can mount this as read only. Read only. Yeah, I can use wildcards inside those files to designate what I want to share. And, you know, use wildcards like a star, which says all systems. Here are some more share options. This would once again be in that DFS tab or export FS. So I can do share as read only or on the command line. I can do it one of three ways, folks. Either in the export FS, and just out of curiosity, let me look here. Yeah, it doesn't look like he's got it configured. I was just curious if he did. He doesn't. So I could have these options. They would either be in the export FS, the exports file, or that DFS tab. And read write, no root squash, allow normal access by root, dangerous. All squash, maps all UIDs to their anonymous versions, no access. So I could designate block access to this directory and subdirectories. Let's see. Insecure lock, specify less stringent locking criteria. You wouldn't want to do that really. But these are all different options when I do, once again, either in a file I put to share because I want it to be permanent, or if you do this, folks, it's not going to be permanent, meaning when you reboot it, this is gone. Okay, this is gone. It's only going to be while your Unix system is live, but if you reboot, it's gone. So what do we do? Well, if you remember, where's it at? I think oh, yep, right here. That export FS or DFS tab. Well, this is where we put the shares in the exports and the DFS tabs, okay, to be permanent. So we put that on an NFS server, permanent, and what those files look like are like this. So command line, temporary. In the files, permanent. And there's all the different rules we could put to share or export, and see how it says common export options. Here's FreeBSD. Allow mounts at any point in the file system. RO, export read only. So the NFSD daemon is what runs on the system. Ubuntu, SUSE, Red Hat, Solaris, HP UIX, okay? And AIX run an NFS daemon that allows you to basically share out those file systems. But on the client side, usually you have to run something on the client side. Now, it could be just that you want to mount it, and it'll mount over it. But notice over here, they're just telling you, well, how many NFSD server daemons do you want to run? This is used basically so that you can mount multiple file systems across the network. So here, like I can have up to 16. The default is 16. That's because usually that's a default for an NFS server, okay? Here's the config file, sysconfig NFS for Red Hat, Solaris, in a default NFS in the ITSC directory. All config files for our Unix systems are in /etc. Okay, and here they're showing you from your book, Red Hat, sysconfig NFS, FreeBSD, rc.conf has some NFS server flags, and NFS kernel-server for Ubuntu, some additional config files. So if I do a show mount -e monk, I can see that I have an export list for home bin and harp.atrust.com. To mount a file system in version 2 and 4, we do mount -o, read write, hard. Now this is a problem. When you mount over the network this file system, and what we're mounting is monk home bin to /NFS bin. So the file system home bin is on the server monk. And you can see right here, it told us, hey, I'm exporting, meaning exporting across the network home bin, just like you export goods from another country, right? You can export a file system on a server to another server. So we're exporting on monk, the file system home bin, to a server called harpatrust.com. On harpatrust.com, we want to mount it so we can use it. Well, in this case, here's the rules right here. Read write, mount it hard, allow interrupts, and background it. Background it means put it in the background where we can't see it. Otherwise, this will be stuck there forever. And if you control C it or close it, okay, it then terminates the mount. So you want to mount, put it in the background. But here's the thing. If it's hard, it's going to lock. Hard means that the NFS server is down. And we usually don't like to do this because all of a sudden you do a command like df. Remember, df was to get this disk file system right here. You do this and it'll hang. It hangs because it's trying to read the disk space off this NFS mount that you just did, but it's down. Now, this is the server, Monk. The directory is home bin, and we want to mount it to NFS bin on our HARP system. So if I do a CD to /NFS bin, I'm actually accessing home bin. Okay. So it's again, I'm doing a CD to /NFS /bin, and really I'm going out across the network to a server called Monk, and I'm really operating on home bin on this system. I'm just mounting it over here on HARP because that's where I need, Ben needs his directory. Now, you'll notice slight versioning difference on version 4 of NFS, which gives us that additional security. Mount, NFS 4, read, write, hard, pretty much looks the same, okay? Pretty much closely looks the same except for the NFS 4. DF, and notice that when you do a DF, you see how it shows where it's from? So Leonard home bin is mounted to NFS bin, and it gives us all the available space and everything on it. Okay. Unmount works on NFS just like a local. So that mount command works on a disks partition just as well as it works for an NFS partition. And then here I can unmount NFS busy, but look at this. Device is busy. One of the problems with unmounting is that, and by the way, you have to be root to do the mount and the unmount command. See, notice the sudo. We also have to do the sudo in front of this as well. You got to be root. But if I mount and unmount this, notice that it's busy. It is busy because somebody's in there working on it. Even if you just do a simple CD NFS bin, it'll show it's busy. Now, you can use a umount -F and force it, but you really want, folks, you want to send an email saying, hey, we need to unmount this. It's no longer being used. Please exit this, location, or exit your computer so we can unmount it. Here are some mount parameters. Read write, read only, background, meaning if the mount fails, keep trying until it continues. Hard, if the server goes down, make operations that access it block until it comes back up. That can kind of cause a little bit of a problem with some commands. I've actually had where it literally has caused monitoring tools to spit out and get hung up because it's trying to do a DF command and can't do it because it's hard. Soft, on the other hand, if it goes down, make operations that access it fail and return an error. This is what we normally do. We don't want to do hard. We want to do a soft mount because it will give us an error and make that operation fail. INTR allows users to interrupt block operations. No interrupt, don't allow user interrupt operations. Retrans specifies the number of times to repeat the request. Retransmit. Set timeouts. We can set the buffer size to improve performance, meaning the amount of memory that is being used to transfer data to and from the device. And then set the NFS protocol version. So we can also put it in the FS tab for Linux or the VFS tab, just like I showed you here. With the FS tab, we're mounting file systems like root, but we could also in here put mount home from NFS home, type NFS or NFS4, read write, background, interrupt. I can put this in concerns, direct hard mapping in the FS tab, and it runs at boot. You can actually get it if you do these hard instead of soft. It'll print an error out and keep on booting your system. Hard, it can actually stop the boot of your system because it's sitting there waiting for this to complete. And you put hard. We never put hard into an FS tab. Never. Because it will hang your Linux system. If server Monk is down, well, your system hangs waiting for Monk to come up. Instead, ROS, if ROS goes down and it's soft here, it'll give an error. ROS not available and boot up. So we always use soft in FS tab. Now, remember that mounting, that auto mount I talked about? Well, this is it, auto mount daemon. I go in and I configure these files, and these files have and point to maps that we want to mount automatically. Automatically means if I move into the directory where it's supposed to be mounted, it'll automatically mount it. If I move out, it will automatically unmount it. Not immediately on the unmount though. So you have two files. One is auto_master for Solaris and auto.master for Linux. They contain the same thing, either an indirect map or a direct map. An indirect map is, it puts everything under a common directory. For example, under a file system called ChimChim or under a mount point called ChimChim, I put users, developers, or info. So it would mount it /ChimChim/users /ChimChim/develop /ChimChim/info. And then here, so it's mounting harp harp users under /ChimChim/users, or /ChimChim/development is coming from the harp-development. So this are where it's coming from, and this is where it's going to mount it on my system, but under this directory. That is called an indirect map. Indirect because it's not using full path name. If I want to use full path name, let's call it a direct map. I say, okay, user source, I want to come from harp user source. So I'm mounting harp user source to /user source. I'm using full path name instead. That's a direct map. Now, here we go. Here's what this auto master or auto.master look like. This is a master map file. When the auto mount daemon comes up, it starts by reading the auto master or the auto_master or auto.master. Here it says, okay, whenever you see the /dot, this is going to be a table that basically puts it full path. / and see how it says *dash, that means do the full path. So this down here would be an auto direct, see, user man CS tools. And here /harp, it's telling it to create a directory /harp and put everything in here in basically an under harp. This is an indirect map. So in other words, it would mount just like you see here. See, it was /harp instead of /ChimChim. It would, this is what that map file would look like. The indirect map file would say, okay, /harp/users /harp/dev /harp/info. Okay, so full path, mount everything in this under /harp. Okay, identity mapping. We can basically, one of the things we can do is you do user at NFS domain and group at NFS to map using identity. Okay, as in who can and can't map. Okay, and then here's some of those configuration files. NFS stat shows us, well, and gives us information. Do we have any NFS going on? See, look, client NFS. What do we have going on our client? Client in this case would be a NFS client, and we're mounting from an NFS server, and it just gives us information, okay, as to, you know, some stats or statistics. A lot of times we feed this into a monitoring tool. We're looking for bad calls as an example. So an NFS dedicated file server, which is kind of what I've been talking about, been around for many years. They're optimized for file service and provide the best possible NFS performance. They're more reliable than standalone boxes thanks to their simplified software. They provide services as well, and a lot of them others for both Unix and Windows. And some of them have other services like web or FTP or SFTP. They do other functionality, or Samba. And they're often easier to administer than Unix file servers. They include backup and checkpoint. So there are where you can go buy dedicated solutions for NFS. Okay, versus I can build a Unix box, I can add a bunch of storage, and then I could set it up as an NFS server by running the NFS daemon very easily. But I could also buy a turnkey appliance or turnkey solution. Here is more reading. You want to find out about NFS. Here you go. Look at the RFCs. And that is it for NFS. Any questions? Any questions? Is there no one in the chat session, or feel free to ask a question? Okay, give me a second here. I want to take a look. Sure why that one's up. I think that's left up from my last class. Hey, hold on. Let's see how many slides this is. You know what? I am going to cover this because that'll catch us up on lectures. And it's only about 12, 13 slides. Okay. So this one's a pretty short little lecture. So as you can see, NFS, if I want to share a file system, is compatible with Microsoft, but Microsoft has to use NFS protocol. What if, and what about a Microsoft share? So just like with Unix and NFS, you can share file systems. Well, Microsoft has its own little file sharing system. Okay. Hold on. Give me just one split second. Okay. So, Common Internet File System. Okay. It was released by Microsoft. Shares files across a network. And then they kind of improved it with server message block. It's more user-friendly. It's still kind of referred to CIFS, you know, which was deprecated. But server message block allows us from the Microsoft side of the house to basically share file systems. Okay. So it is basically the, I don't want to say equivalent, but it does, let's say, you know, it does kind of the same or similar thing as the NFS does. It allows you to share a folder across the network to another device. It was released by, so CIFS released by Microsoft, and it provided 5 basic services: file sharing, network printing, where you could share a network printer on the network, authentication and authorization, name resolution, and service announcement. With basic file sharing, well, you could share home directories like this. So, what if we want to then be able to talk to this protocol, the Microsoft Share protocol, to say mount a Windows share onto a Unix system. That sounds pretty cool, right? Now I can have my Unix system out there, and I can have a Windows server, and I can mount a Windows share using SMB protocol. Well, they came out with a program called Samba, popular software package. No, not the dance. Samba, Samba, Samba. Nope. It is basically, it's available. It's GNU, open source, and it implements the server side of the SMB protocol on Unix and Linux hosts. It allows us to mount a Windows share onto a Unix system. So pretty cool. Here we go. SMB versus NFS, user space, servers and processes, per user processes, uses underlying OS for access, mounts usually individual users, pretty good performance. NFS, kernel server with threads, same server for all clients, has its own access control, mounts usually systems, best performance. So NFS, better performance than Microsoft. Woo! Unix rules. Okay. Although we explore only file sharing in this chapter, Samba can implement cross-platform services. For example, we can use Samba for authentication and authorization with Windows onto Unix. Network printing. Yeah, let's say that the printer's on Windows and shared on Windows. Well, we can print to that server. Saying that though, as long as we can communicate with a print server, it's pretty easy. Okay, we don't necessarily have to use Samba. We can actually use Unix's print services to communicate to a network printer. Name resolution and service announcement. For example, what if you want to browse a little bit and find out if there's any printers or file servers out there? Well, Samba allows us to do that. So, Samba, let's see. Installing and configuring Samba. Well, first you have to load the program onto a Unix server. And Samba, here's an example of Samba as an Active Directory domain controller. It uses an smb.conf file. And here you can notice that they're in ulasa.com. It's giving it the IP address for the password. Now, what is an Active Directory? Let me ask you this. How many of y'all have had the Windows Server class? Answer yes or no in the chat session. Have you had the Windows Server class? Oh, a lot of you know? Oh, you're taking it now? Okay. If you haven't, I would recommend you take that class, folks. Unless you're a programmer. Well, even if you're a programmer. Because you need to know both. So in the Windows world, Windows was designed, Windows Active Directory and the Windows servers were designed for companies to be able to control desktops. We don't want desktops out there that a user has the ability to load their own software, go to any website that they want to in the world, have a root administration on it so they can modify and make changes to it. No, we want to lock them down. Using a Windows server running Windows Active Directory as a domain controller, and you set up a domain, hence ulsah.com would be our corporate domain, and we bind that in to we go to each one of the desktops and laptops and we bind it into that Active Directory domain controller. When we do that, we can then set up a ton of policies and rules. We can say, okay, you are not allowed to load software onto the system. You have to have centralized logging into your machine, meaning we manage usernames and passwords with Windows Active Directory. We can set password complexity. We can say, well, you know what? You work 8 to 5, so you can't log into your computer only from 8 to 5. After other hours, you're not allowed to get into it. We can say, okay, all these printers out there, you're only allowed to access this printer in your cube area. You're not allowed to access the one in the executive area or anywhere, or in finance or anywhere else, just your printer. Data shares, those shares that we're talking about right now, you're only allowed to mount the one that with your home directory. Now, this developer group over here, they can do their home directory and this share system that we have for their tools. So with Samba, we can tap in to that Windows Active Directory. We can allow it to basically align UIDs and GIDs with usernames on a Windows Active Directory and Unix, between the two of them. When we install and configure Samba, well, etc samba smb.conf file is the configuration file. Notice, look, I can set engineering, create a group called engineering, and here I can say, okay, you got to be in the engineering group, and you're allowed to mount home engineering. Realize home engineering is potentially coming from a Windows system. Likewise, Samba will let us share our system onto the Windows side using this protocol. You can actually mount both ways, going both ways. I can either mount a Unix system using Samba over there, or we can mount theirs over on our system. Here's where we're creating, those initial masks when folks have access. And then here is, look, we can make it read only. We can say, oh, it's not browsable. Okay. So there's a ton of settings that allow us to integrate. So here we go. Let's go out here. And if you are interested, you want to play around with Samba, here we go. How to install CentOS OS 7 for file sharing on Windows. Okay. Install Samba. We use Yum. Once we get it on there, well, you got to set up your firewall. And then once again, you could even, I would say you could even share out and play around with this in your virtual sessions, and then share, your file system and mount it on your Windows system. Okay. So here we go. Notice path, SRV, Samba, anonymous. But, if you wanted to play around with basically, mounting and see, look, here we go. CentOS. We created a share drive we're going now from Unix to Windows, from Unix to Windows. You want to be able to mount those Unix partitions onto Windows. And you can go the other way as well. Okay. So here we go. Look at this. Sorry about that. So now look at this. Mount CIFS, username Joe, from Redmond, Joe's, and home. So I'm mounting basically to home Joe mount a CIFS file system from Windows. I can do it manually here as well. And here we go. I'm mounting -type SMBFS. Okay. This is for free BSD. I'm mounting it from Joe's system. Now, and see this Joe this is say I want to log in as Joe at Redmond/Joe's to home Joe mount. And then here, SMB client, I can also use the SMB client to do the same thing. I can say, enter password, domain work group. And these are some of this is a L, so you're actually doing a list. I'm listing //hoarder, and the user's Dan. I'm logging in with Dan's password, and it's telling me that I can, basically I have docs, backups, or programs that I could mount onto my Unix system. So once again, we can go both ways. We can go using Samba. I can mount a Unix file system onto a Windows, or I can mount a Windows on to a Unix system. In this case, using that SMB client. SMB security, explicitly specify which clients can access the resources by Samba. This is in the host.allow clause in SMB comp. So I can also say who can and can't use or can or can't mount or what they can using host deny and allow commands. I can block access to a server from outside the organization. So here's where we're querying Samba state with SMB status. You'll notice here that it's telling me I've got admin, suite depot 2, clients and clients, giving me IP address, telling me that they're connected. And then it even shows me, look, locked files, home clay, atrust admin, what the mode is. Because it's, it's stateful. It's tracking who's got what open. So you don't have somebody on the Windows side or Unix side opening the file up at the same time. We can configure logging with smb.conf. Here's the max log size, syslog. So we can configure logging so it logs all the information to syslog. And that's it with Samba. Now, folks, I could spend 2 or 3 lectures going over Samba as well. Some of this technology, NFS, So if you want to know more about it, well, that link is in this presentation, and you can go out there and play around and configure it and set up yourself exactly with the virtual systems that we're using. You can go and load Samba, and then you could share the file system and then mount it over on the Windows. Okay, you could share your home directory and then mount it as a mount over on the Windows side. Okay. Any questions, folks, on our lectures today? Answer no in the chat session, or feel free to ask a question. Okay. Well, give me 2 seconds here, and I will close this down. We're almost done. We'll go over the labs here. Oops, no, I didn't want to do a stop sharing. Sorry about that. Let me get that back up, which means that chat and participants is going to be, oh, cool, the chat stayed up there. Okay, did I get one more person that joined here before I took roll? One more time here. Okay. Let's get rid of that. Got no more presentations. Okay. Let's see. Just remind me, folks, because I've been yammering here for 3 hours. Did I go over the schedule? Yes or no? Did I go over the schedule at the beginning? Okay. Once again, that midterm should be done. You haven't done it. I would get her done. We're half done with this class. Okay. Okay. So let's bring up today's lab. And as a matter of fact, probably should have kept that up so I could double check the lab here. So today is the last, well, tomorrow's last day, but lab 9. So let's bring up lab 9. Everybody ready for Halloween while I load this up? Got your candy out. And okay. Okay, so today's lab is a print server lab. Now, here's the thing, folks. If you have a network, how many of y'all have a network printer in your home? Enter yes or no in the chat session if you have a network printer in your home. Okay. So a lot of you do. You have the ability, not required, but you have the ability. As a matter of fact, if this was in class, this would be required. I required you to use the in-class printer, but you can actually print to your home printer with this. Now, once again, yes, you have to install the software. Okay, I want you every single time to install the software. The only thing that changes, so the process that you've been doing in the last 2 labs right now is exactly the same. The only thing you have to do, really, and I just copied and pasted this, folks, but really all you have to do, see, I tell you right here, is go down to the section that says, okay, what software should I install, Professor Wade? Because the rest of it, well, you should know how to do by now if you've done the other 2 labs. And I've taken you through it, so you can always go back. For those of you that are way behind on labs, hopefully not too many of you, and I hate giving those Fs. You can just go back and watch, because I actually did the install of CentOS. But the main difference between these is what you're going to install. So really, if you move right down to here, this section right down here, I tell you, do the server with GUI. And then I tell you, click on KDE and print server. KDE and print server. And once you're done, well, you install the software. Okay. I'm not going to go through everything again because I've gone through it once. You can go back and watch the video if you're like, how do I do this? I forgot. And the whole reason that I'm having you install the software, every single one, because by the time you're finished, you can truly tell somebody, yeah, you need me to install Linux for you? I can do that. No problem. No problem. So all you have to do here is click KDE and the print server. And I don't remember if when you do server with GUI, if KDE is already clicked or not. I don't remember. But what we're doing here is the print server. But you have to have the GUI. Not going to work if you don't have the GUI. And then, of course, that's just the regular stuff. And then up it comes. Now, notice you log into the system and you're going to go to HTTPS local 63. Now, look right up here at the top, folks. What does this say? What does that say? You're going to log in as what? Your regular user, or you're going to log in as root? I'm going to say this again, root. In the chat session, type in, what are you supposed to log in with? Your username or root? Everybody. Why am I, do I really want to make sure that I drive this point home? Folks, it won't work properly. It'll come up, but part of this requires root administration. So what you'll get, and here's what I get people that'll submit labs, tells you to log in as root here. I don't know, maybe I should have put it in giant bold letters, but they don't log in as root. They log in as their regular user account. And then all of a sudden they submit a lab because it gets down to, where's it at? Right down in here when they add a printer. And it doesn't, it comes up with an error. And they go, I couldn't add a printer. I tried everything. It won't let me. Did you log in as root? Oh, I'm supposed to log in as root? Yep. Log in as root. You don't log in as root, this lab won't fully work. So you log in as root, and to access cups, and we did go over cups in a lecture. I probably should have moved this one down further, but I had to get you to install this, and the print server chapter was a little back a few. You can always go back and watch the video on that, but we kind of went over cups. Cups is a print server software that we loaded when we clicked the little button that said load the print server. It runs from a web-based GUI. So you have to use localhost 631. So you have to bring up Firefox here, bring up Firefox, and then basically access it from the URL right here, port 631. It brings up cups. And then I ask you some questions. What is cups? How does it work? write a little paragraph, place it in a Word document along with any other screenshots to submit to Blackboard. Click on each tab at the top and describe the purpose for administration, classes, online help, jobs, and printers. This whole first section right here is really just for you to become familiar with cups. Here's the thing, folks. When you do these labs, or any instructor's labs, mine or anybody's, don't just do the lab and go, okay, yeah, it worked. So the instructor is giving you most of the instructions, giving you the A, B, C, D. Understand what you're doing. Investigate it. Enter the help and read. Why am I configuring this? What am I doing here? Don't just do something and don't understand what you're doing. You need to research it or ask the professor, hey, I'm not understanding this. Why do I need to do this? What's it doing? I mean, you're going in this lab and you're configuring a printer. You have software that is designed to act as a print server. Remember, we discussed that, where it builds a print queue. Print jobs come in and they go out. Now, you may not be able to do a print job with this because you have to link it to a legitimate printer. Okay? But you can at least configure it. And you can also configure your real printer out there if you can get to it. Now, how do you figure out if you can get to it? Well, you go here, you see where it says terminal right there. You open up the terminal and you see if you can ping your network printer. If you can ping your network printer, you can actually submit a print job to it. And I've told students, and I'll tell this class, I'll give you 2 extra points on your grade if you can prove to me that you did your printer. Now, how do you do that? Well, you get the page that's been printed out. You can take a picture with your camera and you can submit it with your lab. And I can tell, believe me, because it prints a specific page that looks a certain way. I had one student say, well, Professor Wade, I printed out to my printer. Can you give me my 2 points? And I'm like, 2 extra points. And I said, really? Well, there's no proof here. You know, you have to do the page. Show me the page. And I don't remember, they printed like a log page from this. And I said, no, I want the actual printed page. You know, the one that comes out of the printer. Like, oh, okay. And then finally they gave it to me. But I'll give you 2 extra points towards your grade if you get it to print out. But I have to see it submitted to Blackboard. So you're going to have to take a picture of it, email it to yourself, and then submit it as part of the Blackboard with this, you know, here. Okay. So here's the cups menu. You can see right here. You can go in here and do a little research, overview of cups, adding printers, managing policies, printer activities. You know, you don't necessarily have to look at the developer. That's for developers. Okay. And then here, answer the following questions placed in a Word doc. What command lines are used to print a file on the Linux server? Guess what, folks? Look right there. I actually circled it for you. You click on online help, command line printing and options. That's all I got these questions from right there, because Cups works with a GUI, but it also works with a command line. Most Unix people, if there's a print server out there, they don't go to a GUI and go print. Those are Windows people. We're not Windows people. We're Unix people. We're the best, awesomest people because we know Unix. Okay, I'm a Windows person too, folks, but I like Unix. I have more Unix experience than I don't know, more Windows server experience than more Unix experience than Windows. I got like 40 years of Unix, and I've got on the Windows side maybe 10 years of server experience. You know, 10 to 12 years. Anyways, there's the command line option. So we would write a script potentially that might print out, you know, a report or something like that. And then I say, well, what options can I use? You know, you can look through, type, or you could copy as well. I don't mind if you copy from this, you know, and just show a copy of it. So if you installed the security module, do this anyways. Type this anyways in there. It doesn't matter. It comes with a default security module now with the current version. Then log into Cups. When you log into Cups, you got to use root. Use root. So log in as root and also log in here as root. Don't use your UC. Use the root login and password you gave during installation. See if you can configure a network printer, regardless if you can or can't. Take the screenshot, place in the Word document. Folks, you can configure a printer. Everyone's done it, okay? So all you're going to do here is add printer right there. Click on the add printer. Here we go. Here's the add printer. You're going to type in IPP, Internet Printing Protocol, and continue. Then you're going to configure the socket. And this socket, you see this? Socket : / 192.168. That IP address is your printer. So if you have a printer on the network, that is going to be the IP address of your printer. Okay? See, it says, see network printers for the correct URL to use with your printer, but you're just going to use this. This should work. See, they're just showing you other possibles that you could use, but this one here, everybody in class was able to print to the printer in class, everyone, using this. The only difference here is the port number is still the same, 9100, but this IP portion is going to change. Okay? Then provide the printer a name, HP printer, lab classroom, okay? And then once again, see, there's the socket. Notice the colon. Everyone should know when you're looking at a URL, or okay, that you can use ports. That's a port, :port. I may have a web server that doesn't use port 80, it uses 8080, and I could use, just like this GUI, look right up here. This is a URL. It's using port 631 because this application is opening up a web server to run it, and it is using port 631 instead of 80 because it doesn't want to conflict with any web servers that are out there. So it's using port 631. Then I click share this printer, continue. And now, as part of this add printer part, so see, I've given it a name, gave it a location. You're looking at the make. And you got to, sometimes your model might not be there, but you can find a model that is close as possible. Like if it's a laser jet. So here, look, HP, and then you select. So see, look, if it's a laser jet, you know if your printer's a laser jet or not, it'll be called a laser jet. But maybe you don't have a 4015, maybe you got a 4016, or maybe you've got a a 4100, and this is the closest it comes to. You can try this. Now, here's what will happen is if it isn't the right model or close enough, when you print out to it, you'll get gobbledygook on the printer. It'll just literally start spitting off pages. You got to cancel the job. You can cancel the job here, but it'll print gobbledygook. If you get the right one close enough, it'll print the page. 2 points, 2 extra points towards your grade. And then finally, you give it options. For example, what's the media size? Is it double-sided? Do you want to turn it off or on? Or you could just leave the default options. Once you're done, set default options. And now look, accepting jobs. Now, a lot of times you'll get an error that it can't connect necessarily to the printer. But then once you're done there, what you can do is, and I took it off, okay? I did take it off the requirement. There used to be here an option 15, and the 15 said, go in and click on the printer. See where it says maintenance or administration? One of these drop downs here will allow you to print a test page. That's how you print a test page. One of these options, maintenance or administration, will say print test page, and you print a test page. I took it off. Why did I take it off? Well, because of COVID and because we're not in the classroom and not everyone has a network printer, and not everyone, if they have a network printer, may not have something that is as compatible with HP. So it's not required to print a printer page out to your printer, just if you want to have a little more fun and go, ooh, let's see, awesome, I got a page to print. but you can print a test page under the maintenance or the administration window. Okay. You can do the same thing with Microsoft, by the way. Microsoft, you can click on the printer and then you can say print test page and you can print a test page for Microsoft. Okay, that's it for Lab 9. Any questions on this lab? We are setting up a print server. And if you remember, what's the job of a print server? It is to combine all of our users to be able to print to the same printer, but to have a print queue so we can manage print jobs. Because what you don't want happening is, and here's legit what happens. They don't have a print server, but they share a printer. And somebody spits off a job and they spit off a wrong file type or something else, or they accidentally printed an entire PDF, which was 250 pages. I've seen that even in classrooms. You know, they print off something and they think they're printing one page, and instead they're printing 250 pages. And you go over there. It's funny because I'm in class and all of a sudden the printer would go, dum, 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 and I go over there, you know, and it keeps on going through the lecture. And I'm like, and I go over there and I go, hold on. And I'm like, who's printing a whole book? Okay. We don't. And I go over on the printer and I cancel the print job and say, okay, folks, we don't want to use this. It's there to print out, you know, 2, 3, 4 pages, something like this, not a book, not a 250 page book. You know, and no one ever confesses. No one ever goes, oh, sorry, Professor Wade. Yeah, I was trying to print out this. You know, nobody says anything. So probably I shouldn't put them on the spot, but you know, or they'll print the slides off. And when you print slides, you can print 4 little cubes, you know, 4 cubes or 6 cubes. Each little cube is the slide. And I'll get some folks that'll print the whole slide. And so, you know, if you have 60 slides, it's single page, 60 pages, and then I go over there and I'm like, okay, I understand you want the slides, but we don't need to print one page. You can go in and print, you know, give it a format and tell it to print it in, you know, 4 slides per page, 2 slides per page, whatever. But let's not print, you know, this is 60 slide deck here, folks, you know, and you're printing single page. And because they want us to kind of cut down on the pages, they don't want, you know, those pages, the ink and everything, that's expensive. You know, ink is more expensive than the printer nowadays, pretty much. So yeah, so the main reason we have software like this is so we can manage those print jobs. So if somebody's computer does go nuts and for whatever reason starts spitting out tons of pages, well, an administrator can go here and cancel that person's job. And the job is on the print server. It's not on their PC. And then they got to go call the user up. Are you printing this? Yeah, could you stop it, please? Anyways, that's what a print server is for. It's to help with sharing, you know, and in some companies, they have a room with like 4 giant printers and, you know, it'll print a cover page. You can also configure your printer and choose, hey, I want a cover page, and it'll put your username. And so then they have little mailboxes and they'll put people's print jobs in the mailboxes. So I worked in a few places like that. I haven't seen as many anymore because printers have gotten a little cheaper, but back in the past, some companies, and they still do, I still see it. They just have that centralized, you know, printer office. Okay. Any questions on, you know, this lab or, you know, I know you haven't done it, but any questions right now on this lab? Answer no in the chat session if you have, or feel free to ask a question on any of the lab requirements. As always, folks, I don't need all the instructions, you know, so, so please don't submit all the instructions. It always, it's a kind of a pain when, so look at this. I got 14 pages of instructions. So I have to thumb down 14 pages, plus 14 pages are stored digitally online. We don't need that. All you got to do is go here, you know, go down to that page 14 and go all the way up to the top. And once you get to the top, here we go, bang and bang. And I could have gotten rid of that, but the questions really kind of start right here. So you can get rid of everything but, the questions, and then answer them in line. Okay? Answer them in line. So here's some more questions. And then what do I want? What's the requirement for this lab? Answer those questions and show me this page right here. Show me this page. And by the way, choose a different printer name than I am. I don't copy this and try to paste it. I want to see a different IP address. So use a different IP address. Try to use your real printer. Try to do that. Get the 2 extra points. But change the description of the printer. Use your name, like HP under printer under J Wade, as an example for the description. So I can validate that indeed you got to this point right here. So answer the questions, submit this right here so that I can go, oh, yep, they got it. They did it. It says HP printer, J Wade. And for those of you that, once again, if you have a network printer, you want to do it, print to it, take a picture of it with your camera, or if you have a scanner, or if the printer's a scanner, and then put it right below here. But I've got to see the test page that prints out, and then put it right below this one. Okay, so 4 things you can turn in, 3 required, 1 optional. These questions right up here. These questions here, how do I cancel a print job? These questions here, what is cups? And finally, this page right here that shows, look, Professor Wade, I have got a printer configured with my name right here, right there, that bottom one. There's the printer. And then for those of you that want the 2 points, do the test print job and basically pop it right down here. And remember, you got to be able to ping your printer. So log into your system, the system, and pull up a Unix terminal and see if you can ping your printer. Okay. Okay. Okay, folks. Well, that's it for class. That's it for our labs. At this point, I've already taken roll call. You can dial off, or if you have some lab questions on other labs, you can feel free to ask those. Or you can stay. Sometimes this class get out. I think it gets out in like 10 minutes. What is it? Hold on a second. Yeah, it gets out at in about 10 minutes. So anyways, if you have any other lab questions, feel free to ask those. Once again, we're over the halfway point. If you haven't caught up with that midterm, and today we finished chapter 22. We got to chapter 22. So by next Saturday, you want to get lab 9 done and have all the other labs done. And you want to get done with chapter 21 and 22 quiz. Okay. So finish all the way to chapter 22 quiz and get done with basically up to lab 9. And then we'll go over lab 10 next Saturday. And I'm going to go over chapter 23 and 4, which is configuration management and virtualization. Okay. So have a wonderful, happy Thanksgiving tomorrow. Have fun. Don't eat too much candy. I can't anymore because I have a little bit of diabetes, but have a great one. And if anybody wants to stay and ask lab questions, feel free. And I will see you all next weekend. Okay. Happy Halloween. I'm muted. I'm just sitting here talking away, going, why aren't you replying? Is this where you're talking about, Alicia? Is that, and if I pronounce that wrong, I'm sorry. This, is this where you're talking about right here in the lab? Okay, so I've got to know like where you're talking about in the lab. I'm using the VM's IP, but I don't know. I can't get the web page to start up when I reboot. So if you can't get the web page to start up when you reboot, then it's one of two things. One is you didn't go up here and do the system CTL enable HTTPD right there. That's what gets it to start up. Okay, so you did that. Okay, great. The other reason is, and what you can do is go look in the log file. You go look in the log file, but the other reason is you got some kind of typo here, right here. Now, if you want, you can share your screen. Okay, you can share your screen. But did you get to this part? Did you get here to configure this? Yes or no? Did you get to this part right here? Oh, okay. Well, then it should still come up. Now, where you're going to go, you type in to your console window. I mean, if you want, we can share your screen. Share your screen and I can take a look. You want to share your screen? Have you got your virtual machine up? I'll make you the presenter. You are now the presenter. I noticed a few more still dialed in. Amelia, Easton, Nicholas, and Seth. You guys got any questions? Y'all ladies, anybody have any questions? Nope, there's somebody dialed off. Okay, so for me to help you, you're going to have, it should work just fine, but you're going to have to, did you ever get this page here? So really all I can tell you, if you can't, bring up the VM and share the VM and us work on it, is just go back over the instructions each step and make sure it does indeed work. For example, you could bring up the VM, do a PS-EF and see if HTTPD is running. Okay. If it's running, then you should be able to get to the web page. Now the IP may change every time you boot it. So you have to log in, and where did I show that up here? You have to log in to it, and you have to type in basically ifconfig, because in order to get to the web server right here, so here you can go back up to this step, reboot, do a PS-EF, and then go grep for HTTP. That tells you, yep, it's running. And then you right into the same virtual machine, you type in ifconfig. That gives you the IP address of the web server. And then that's where you use your HTTP, not S, but HTTP, and whatever the IP address of that web server is. And you bring that up in your regular Chrome browser on your Windows system. Okay. Yes, the IP of the VM. This IP of this VM right here. You log in, you type in PS-EF. Yep, this is running HTTPD. Then you type in ifconfig. I'll type that in the chat session right there. And then once you type in ifconfig, then Easton, Nicholas, Seth, I notice you're still out there. You have any questions? Or no in the chat session, or feel free to ask a question. Hey, let me stop. Did I stop the recording?